Hello there and welcome to Life Beyond Seen, where curiosity drifts gently between science and stillness, and where the mysteries of our world unfold at a pace your mind can follow without hurry. Tonight, we're not looking up at the stars, but down, far down, into a place that very few have seen and even fewer understand. It's a world beneath the world, deeper than any diver can dream of, quieter than a graveyard of planets, and darker than the space between galaxies. It's called the Emden Deep, a place so hidden and untouched that even scientists speak of it with a kind of reverence, as if mentioning a ghost. Somewhere in the western Pacific, under miles of restless sea, lies this unexplored abyss. It's part of the Philippine Trench, an immense scar in the ocean floor, a place so deep and remote that if Mount Everest were dropped into it, the peak would still be swallowed by water. Before we begin our slow descent, I'd like to ask something simple. When was the last time you thought about the ocean, really thought about it? Not the waves lapping on a beach or the glint of sunlight on the surface, but the unseen depths that stretch below all that motion. Have you ever stood by the shore, looked out, and realised that everything you can see is only the thinnest film of what exists? Maybe you felt that quiet tug of curiosity, wondering what happens beneath the blue horizon where light begins to fade. That curiosity is what guides us tonight. So wherever you are, whether it's late evening or early morning, whether you're listening from a small apartment or a quiet room somewhere by the sea, this is your invitation to drift with me for a while. And if this kind of slow exploration soothes you, helps you unwind, or simply reminds you of how vast the world still is, it would mean a lot if you'd like the video, maybe subscribe, and join our quiet corner again. It helps more than you might think. Now, let's begin to sink. Not quickly, not dramatically, but with the patience the ocean demands. The descent into the deep is not a dive, but a surrender. The water thickens around you, the light softens, and the surface noise, the wind, the hum of distant engines, the chatter of life, fades until there's nothing left but the sound of your own thoughts and the slow rhythm of breath. It's easy to forget that this planet is more ocean than land. 71% of Earth's surface is covered by water, and of that most is deep. So deep that sunlight never reaches it. We tend to picture the ocean as a vast blue expanse, calm and predictable. But the truth is it's layered like an atmosphere turned upside down. The top few hundred meters, the part we swim in and sail across, are just the shimmering skin. Beneath that, the light begins to dim, and by 1,000 meters, darkness takes over completely. Keep descending, and the water pressure multiplies until it crushes metal like paper, and far below even that, at depths few machines have survived, lies the Emden Deep. The name itself sounds almost gentle, doesn't it? Emden could belong to a quiet town or an old ship, but it's attached to something unimaginably harsh. It sits at the southern end of the Philippine Trench, about 10 kilometres below the surface. That's over 33,000 feet, nearly 7 miles straight down. To picture that, imagine standing at sea level and looking up at a commercial jet flying overhead. Then imagine that same distance going downward, through water dense and cold enough to stop a human heart in seconds. Temperatures hover near freezing, around 1 to 2 degrees Celsius. The pressure there is more than 1,000 times what you feel right now. Every square inch of any object is squeezed with a weight equal to being buried under 50 jumbo jets. It's a world that doesn't forgive mistakes, yet it's also one of the last truly untouched environments on Earth. What's remarkable is how little we know about it. The Emden Deep isn't famous like the Mariana Trench's Challenger Deep. It doesn't have documentaries named after it or explorers lining up to visit. For decades it wasn't even properly mapped. It was just another shadow in the ocean's cartography, noted in passing by sonar but rarely studied. In the hierarchy of Earth's mysteries, it has always been the quiet one, waiting patiently in the dark. The few expeditions that have targeted it, Japanese, Filipino, American, have returned with only fragments of data, enough to confirm its depth and shape, but not enough to tell its story. Even today, in an age where satellites can count the trees in your backyard, there are fewer high-resolution images of the Emden Deep's floor than of the surface of Mars. Imagine that. We have rovers crawling over Martian rocks, sending back photos of sunsets on another planet. Yet there's a place on our own world where no human eye has seen the ground. The bottom of the Emden Deep could hide entire ecosystems, mineral formations, or geological processes that rewrite our understanding of Earth, and we wouldn't know. The irony of it feels almost deliberate. We spend billions to reach the stars while a whole universe sleeps beneath our oceans, untouched. It's easy to see why scientists sometimes call the Hadal Trenches inner space. The parallels with outer space are uncanny. Both are hostile, both demand complex technology to visit, and both remind us of how fragile we are in the face of extremes. The first people to glimpse the Emden Deep didn't see it at all. They detected it by sound, pings sent down from survey ships that bounce back faintly from the bottom. Each echo took about 14 seconds to return, enough time for scientists to calculate the depth and sketch a faint outline of the trench's shape. Later, in the 1950s and 60s, sonar mapping improved, but the focus remained on the Mariana Trench to the east. The Emden Deep sat quietly, unmapped, unknown, and uncelebrated. Only in recent years have researchers begun to turn their attention toward it again, using autonomous underwater vehicles, robotic submersibles that can withstand immense pressure, to probe the darkness. These machines glide through the abyss without human passengers, their cameras encased in titanium, their sensors whispering data back to ships miles above. Even with such tools, the Emden Deep resists easy exploration. The darkness isn't just visual, it's informational. Signals weaken, batteries die, and even the most carefully built instruments can fail under the relentless crush. It's a reminder that Earth's final frontiers aren't always far away. They're sometimes right beneath us, hidden by something as familiar as water. The ocean is deceptive that way. It seems accessible, friendly even. We swim in it, fish from it, and build our vacations around it. Yet beyond that first glittering surface lies a realm more alien than any desert or mountain. The Emden Deep is the deepest part of one of the most active tectonic regions on the planet. The Philippine Trench itself was formed by the collision of the Philippine Sea Plate and the Sunda Plate, a slow, grinding motion that forces one section of Earth's crust beneath another. Over millions of years, that motion carved a trench 1,100 kilometers long and more than 10 kilometers deep at its southern end. The seabed there is constantly shifting, bending and cracking under unimaginable pressure. It's a dynamic landscape of mud volcanoes, fault lines and creeping tectonic stress. If there's a place on Earth that feels alive yet unreachable, this is it. Descending in imagination through those layers, you'd pass through worlds within worlds. At first, sunlight filters down in shards, a fading shimmer that still glows faintly through clear water. Then colours begin to vanish one by one. Reds and oranges go first, swallowed by blue. A little deeper, even blue surrenders, and everything turns to a muted grey-green gloom. Fish and jellyfish drift past, their movements slow and economical, conserving energy in the growing cold. Some flash bioluminescent patterns, brief sparks of chemical light used to attract prey or confuse predators. They are the last artist of colour before the void. By the time you reach 3,000 or 4,000 metres, the pressure is enough to crush a submarine hull not designed for it. Most life here is sparse, delicate, and astonishingly adapted. Creatures look more like ideas than animals, transparent, fluid, and strange. Then, as the descent continues, there comes a point where the light disappears entirely. It's not darkness as you've ever known it, but the total absence of light. The kind where even the idea of colour feels foreign. Down here, sound becomes your only companion. Not the sharp echo of the surface world, but a low, endless murmur. The shifting of water masses, the distant crack of moving rock, the faint hum of your own machinery if you're in a submersible. Everything else is still. The ocean's heartbeat slows to nearly nothing. It's easy to understand why early sailors and philosophers saw the deep sea as a kind of underworld, a domain of death and dreams. But the Emden Deep is not empty. It's just hidden. If you could see its floor, you'd find a landscape both barren and alive, covered in fine sediment that's drifted down over millennia, forming a record of Earth's history one microscopic layer at a time. Every particle of dust, every bit of dead plankton, every chemical trace tells part of a story stretching back millions of years. The bottom is a museum of time without windows or walls. To reach such a place requires not only technology but humility. The ocean does not forgive arrogance. Explorers who ventured into similar depths like Victor Vescovo, who reached the Challenger Deep in 2019, speak of an overwhelming sense of isolation, a feeling of being utterly alone, suspended between two infinities. The same would be true here. Even communication with the surface takes time. Radio waves don't travel through seawater, so submersibles rely on acoustic signals that move slowly and can be easily distorted. A few simple commands, up, down, turn, stop, may take seconds to relay. It's not an environment built for conversation. You listen more than you speak. And maybe that's the point. When you think about it, the Emden Deep isn't just a geographical feature. It's a mirror. It reflects the limits of what we know, the boundaries of comfort and comprehension. Just as astronomers look into the night sky and see mystery in every speck, oceanographers peer into sonar maps and find blank spaces that defy naming. Those blank spaces matter. They remind us that despite all our data, all our satellites and sensors, the world is still larger than our understanding of it. The Emden Deep exists in that gap between knowledge and wonder, the space where science meets silence. And silence has its own gravity. The deeper you go, the more it pulls at you, the more you sense that the ocean doesn't need to impress or explain. It simply is, vast and indifferent. That indifference can be oddly comforting. There's something peaceful about a place that carries no human history, no wars, no noise, no footprints. It has existed for millions of years without caring whether anyone knew. Perhaps that's why it feels sacred in a way that few landscapes do. Not holy, but pure. Untouched not by choice, but by circumstance. We can't live there. We can barely reach it. And so, for now, it remains what so much of Earth once was. A mystery sustained by distance and difficulty. Even thinking about it changes perspective. Above, life is noisy and fast. Every second brings movement, decision, distraction. Down there, nothing hurries. Time itself feels slower, stretched thin by pressure and darkness. If you were somehow able to sit on the seabed of the Emden Deep and look up, though you'd see nothing, your sense of scale would dissolve. The ocean above you would weigh nearly 10,000 tons per square metre, yet it would all be invisible. The surface would be as far away as the edge of space, a faint mathematical idea rather than a visible goal. The notion of up or down would stop making sense. Only the steady crush and stillness would remain. Yet even in that stillness there is motion. Fine sediments drift like snow, invisible currents slide past, and deep sea organisms move with deliberate grace. Some are shaped to resist the crushing force by being nearly fluid themselves. Others use chemical reactions instead of sunlight to create energy. There are bacteria down there that feed on hydrogen and methane, thriving where no plant could survive. Their existence challenges the very definition of what life needs. Perhaps in that sense, the Emden Deep isn't just an abyss, it's a laboratory, a glimpse into how life might exist elsewhere in the universe, under ice-covered moons or in subterranean oceans of other worlds. Thinking of that connection, the same elements, the same physics, the same fragile persistence of life, creates a bridge between the deep sea and deep space. Both are vast, cold and indifferent, yet both cradle the possibility of life. The Emden Deep could teach us about more than marine biology. It might hold clues to how ecosystems function without sunlight, how chemicals become energy, how structure emerges in chaos. Every organism found there is a survivor of pressures and conditions beyond imagination, a biological answer to a question we didn't know how to ask. So, as we continue this journey into the dark, keep in mind that we're not just travelling downward, but inward, into the planet's oldest silence, into the parts of ourselves that still wonder what lies beneath the surface. Because somewhere below the last flicker of light, in a place no sunlight has ever reached, the story of the Emden Deep is waiting, patient and unchanged. And the deeper we go, the more the light fades, until all that's left is the sound of water and the quiet pulse of curiosity guiding us further into the unseen. The deeper the descent, the more the ocean transforms from something familiar into something foreign. At first, it still behaves like the sea you know. There are currents, flickers of movement, hints of light. But past a certain depth, those signs of life and warmth begin to thin out, replaced by a kind of calm that feels both serene and intimidating. The water becomes heavy, its density palpable, and every motion seems to take longer, as if the ocean itself is reluctant to let anything move too quickly. Somewhere between 1 and 200 meters below the surface, the last threads of sunlight start to fade. What remains is a dim blue glow that weakens with every passing meter, until it becomes less light and more memory of light. That's the threshold, the beginning of the twilight zone, the place where day ends but night hasn't fully claimed the water yet. Here, vision changes. The human eye, accustomed to bright contrasts and outlines, struggles to interpret what it sees. Colours flatten, reds are gone completely, absorbed by the water long before they reach this depth. Yellows are fading, greens are muted, and blue reigns alone until it too begins to dissolve into darkness. The world takes on the tone of an old photograph, drained of colour but rich in texture. Every movement, every shimmer of scales or ripple of water feels significant because it stands out against the growing void. It's as if the ocean is slowly erasing itself from sight, one wavelength at a time, until only the suggestion of motion remains. Marine life here has adapted in ways that defy easy explanation. Many creatures of the Twilight Zone have evolved to see in wavelengths invisible to us. Some have eyes that are disproportionately large, round and glossy, built to catch even the faintest photon drifting down from above. Others, paradoxically, have given up on vision entirely. They navigate by pressure, vibration and smell, living in a sensory world utterly different from ours. Some species use bioluminescence, light created by chemical reaction, to attract prey or communicate. It's an eerie, almost deliberate kind of illumination, small points of green, blue or even red light drifting through the darkness like scattered stars. For a moment, the comparison to space doesn't feel like metaphor at all. It's as though the sea has inverted itself, putting the stars beneath our feet instead of above our heads. If you could linger here and simply watch, you'd see one of nature's quietest spectacles. A flash of light in the distance, then another, and another, until the dark water resembles a slow electrical storm. Tiny plankton release glows when disturbed, creating glowing trails in the wake of larger animals. Certain squid species emit pulses of light that ripple along their bodies like Morse code messages. Lanternfish, among the most numerous vertebrates on the planet, carry glowing organs along their bellies to mimic the faint light above, disguising their silhouettes from predators below. Each species has its own pattern, its own rhythm, a language of illumination that humans are only beginning to interpret. As the descent continues, temperature drops sharply. The upper layers of the ocean are stirred and warmed by sunlight, but below 1,000 meters the heat disappears almost entirely. The water stabilizes at just above freezing, typically 2 or 3 degrees Celsius, and stays that way for miles. It's one of the most stable environments on Earth, yet it feels utterly alien. Imagine being surrounded by a darkness so complete that even your own body disappears from view. You move, but movement feels abstract. You hear, but the sound arrives distorted, stretched by pressure and distance. The surface world could have ceased to exist, and you would never know. For the life forms that exist here, this isn't alien, it's home. Many have bodies that would collapse if brought to the surface, their delicate structures built to function only under immense pressure. The muscles of deep-sea fish are soft and gelatinous, not out of weakness but necessity. Rigid tissue would shatter under these conditions. Even bones are rare. Many creatures rely on cartilage and fluids to maintain shape. The results are beings that look fragile, almost ghost-like, yet perfectly engineered to endure. Their movements are slow, deliberate, efficient. Every calorie of energy counts in a place where food arrives only occasionally, carried down from above in the form of what scientists call marine snow, an endless drizzle of organic debris, dead plankton, and microscopic fragments that drift down from the surface. It's not a storm of plenty, but a quiet, eternal snowfall of decay that sustains everything below. It's strange to think that death from above is the foundation of life below, but that's how the deep ocean works. The waste and remains of the surface world feed the abyss. Every speck of falling matter becomes a meal for bacteria, which in turn feed larger organisms. Even here, balance holds. Life and death, decay and renewal, all circulate through invisible hands. It's easy to forget that when you picture the ocean from a distance, but down here it's obvious. The surface and the depths are bound together by an endless chain of giving and taking. If you could hover motionless in this zone, your sense of time would begin to blur. There's no sunrise, no sunset, no visual cue to measure the hours. The only rhythm comes from movement, the slow drift of plankton, the occasional shadow of a predator, the steady pulse of your own heartbeat if you were somehow present. It's here that human senses start to fail. Our understanding of the world relies so much on light that without it, we lose track of meaning. We don't just stop seeing, we stop interpreting. Maybe that's part of the ocean's lesson, that perception itself is a luxury of the shallow world. The deeper the dive, the more the water resists intrusion. Each meter adds weight. Each degree of temperature loss feels like another layer of insulation from the familiar. By the time you reach the boundary where light finally surrenders completely, roughly 1,000 meters down, you've entered the midnight zone, a place so dark that light behaves more like a rumor than a fact. The air you once took for granted no longer has meaning. Pressure has replaced it as the defining force. This is where the ocean begins to express its true nature, where it no longer resembles anything from the surface world. The Emden Deep lies many kilometers below even this point, but understanding this transition, the end of light, the beginning of total darkness, is essential to imagining what waits farther down. The twilight zone marks the last negotiation between two realities. Above it, sunlight dictates everything: warmth, weather, colour, motion. Below it, the rules are rewritten. Energy no longer comes from the sun, but from chemistry. Photosynthesis gives way to chemosynthesis. In this realm, microbes feed not on light, but on minerals seeping from cracks in the seabed. It's a quieter form of life, one that depends on patience rather than abundance. To most of us, the idea of living without sunlight feels impossible, but in the deep ocean, it's routine. There are entire ecosystems that have never known day. When scientists first sent cameras into the deep, they expected to find emptiness. What they found instead was motion. Small, deliberate, persistent motion. Shrimp, worms, jellyfish, fish with transparent heads, creatures with mouths that glow like lanterns. It was as if evolution had written a new language to describe existence without light. Down here, survival isn't about competition in the way we know it. It's about endurance, about knowing how to make the most of almost nothing. Food is scarce, temperatures are hostile, and the pressure is constant. Yet somehow, life thrives. If you could ask one of these creatures what the surface was like, it would have no frame of reference. The sun, the stars, even the idea of sky, these are abstractions with no meaning. And maybe, in that way, it's a reminder that the things we consider universal are often just local habits of our own environment. The deep ocean doesn't obey the same logic as the world above it. It doesn't care about our boundaries or expectations. Its cycles are longer, slower, more deliberate. Change happens on geological timescales, not human ones. Some explorers describe a strange psychological effect during deep-sea dives. After hours in darkness, the mind begins to play tricks. The absence of familiar reference points blurs orientation. Up and down become interchangeable. Even distance loses clarity. You can look at an object illuminated by artificial light and have no idea whether it's a metre away or 10. The water absorbs not just light but scale, making the world feel infinite and immediate at once. This disorientation isn't dangerous in itself, but it reveals something about our dependence on light for meaning. When that light disappears, we confront the limits of our perception and realise how narrow our sensory world truly is. Technology, of course, provides substitutes. Submersibles carry powerful lamps, sonar arrays, and cameras that translate the invisible into measurable data. But even with those tools, exploration here is difficult. Light, when introduced artificially, behaves differently. It reflects off suspended particles, scattering into hazy halos. Shadows look soft and uncertain. The result is a world that never quite resolves into clarity. Even the clearest footage of the deep retains a kind of ghostliness, as if the ocean refuses to let itself be fully seen. That resistance feels almost intentional, though it's simply physics, the way light, water, and distance conspire to obscure. You begin to understand why myths about sea monsters persisted for centuries. When your only contact with the deep was a brief glimpse of something rising from below, distorted by water and light, the mind filled in the rest. Whales became leviathans. Squid became krakens. Unknown noises were the growls of unseen giants. In a way, those myths were a natural reaction to the Twilight Zone's ambiguity. It hides enough to make imagination necessary. And imagination, when deprived of facts, always reaches for the extraordinary. As we sink deeper, that ambiguity becomes the rule rather than the exception. Here, near the bottom of the Twilight Zone, the water pressure has increased tenfold from the surface. It's the threshold beyond which few fish can survive. Those that do have evolved remarkable adaptations. Some produce antifreeze-like compounds in their blood to prevent ice crystals from forming. Others have muscles laced with special proteins that remain flexible under pressure. Some species rely on slow metabolisms that allow them to go days or weeks without food. It's not a realm for abundance but for efficiency. Every aspect of life here is tuned to the smallest possible margin of survival. What's fascinating is that this same Twilight Zone, despite its inaccessibility, plays a massive role in the planet's climate. Every year, billions of tons of carbon from surface organisms sink into it, becoming part of the marine snow. As this carbon settles, it removes greenhouse gases from the atmosphere, effectively storing them in the deep. The process is sometimes called the biological pump, and it's one of the main reasons Earth's climate remains stable. Without it, temperatures would rise dramatically, so while this hidden layer feels distant and irrelevant to daily life, it quietly governs the air we breathe and the stability of the world above. The Emden Deep, lying beneath it all, receives the final remnants of that carbon cascade, the end of a process that begins with sunlight and ends in darkness. That's another way of seeing this descent. It's not just a physical journey downward, but a journey through Earth's memory. Every metre carries traces of everything that's ever lived above it. The deeper we go, the older those traces become. The Twilight Zone holds the most recent ones. The remains of yesterday's plankton, last year's blooms, the echoes of life that flourished and faded before we ever noticed. Beneath that lies the record of centuries, then millennia, then millions of years, compacted into the sediments of the deep. The Emden Deep is not only a void, it's an archive. It contains, in silence and darkness, a history of change more complete than any library. Descending through the twilight zone feels like moving through the last chapter of daylight itself. Each layer carries less colour, less heat, less sound, until all that remains is motion and pressure. But rather than feeling lifeless, it feels patient. There's an odd sense of continuity, as though the ocean has been waiting for someone to notice that this transition, the fading of the light, isn't an ending at all, but a doorway. The Emden deep lies far below, but this is where its mystery begins. It starts not in the trench itself, but in the surrender of light, in the acceptance that visibility and understanding will not always coincide. And so, the descent continues. The surface is a distant thought now, the last glow long gone. The sensors hum quietly. The lights narrow into thin cones piercing the dark, and ahead lies the unknown, a world without sunrise or sunset, where existence depends on adaptation, endurance, and the strange beauty of survival in silence. The journey downward goes on, and in that steady fall, the first hints of the true abyss begin to take shape. What lies beyond this curtain of darkness is not emptiness, but a new kind of world entirely. The last traces of blue vanish, and what remains is darkness that feels physical, as though it presses against your skin rather than surrounds you. You're now in a world where sunlight has never arrived, not once, not even as a whisper. It's hard to describe what this kind of darkness means because it's not the same as night on land. On the surface, darkness always carries the promise of dawn. It's temporary, predictable, and part of a cycle we've lived by for millennia. Down here, there is no cycle. There is no sunrise waiting behind the horizon. There is no difference between midnight and morning. This is a world without day or night, where time exists only in motion and metabolism. The ocean here doesn't sleep or wake. It simply is, continuous and indifferent. Temperature has leveled to near freezing. Pressure is no longer a number you can grasp. It's a constant presence, heavier than any mountain, pressing on every molecule of water, every grain of sediment, every living cell. You could imagine the weight of an entire city resting on the palm of your hand and still fall short of what it feels like down here. Yet life endures. That fact alone reshapes how you think about existence. Against all logic, there are creatures here that move, feed, grow, and reproduce in a realm that seems engineered to prevent all of those things. They're not survivors, in the sense we usually mean the word. They're normal residents of a domain built entirely on extremes. What's immediately striking in this abyssal environment is the absence of motion. The water feels still, almost frozen in time, but that's an illusion. It moves constantly, only so slowly and predictably that the human mind fails to notice. Deep currents circulate around the planet, carrying cold water from the polar regions toward the equator and back again. These flows operate on timescales so vast they make human civilization look momentary. A single circuit might take 1,000 years to complete, and yet those currents are what keep the planet alive. They distribute heat, oxygen and nutrients between oceans, connecting every sea into one immense global system. So even though this place feels isolated, it's not. The Emden Deep and its neighbouring trenches are part of a slow, invisible conversation that links all the oceans of Earth. If you could release a drop of dye here and somehow track it, you'd find that it would drift for centuries before surfacing anywhere. It would pass through valleys and ridges on the ocean floor, caught in slow eddies that twist like sleeping giants. Eventually it might emerge thousands of kilometres away, unchanged except for the memory of pressure. This slowness is not stagnation, it's stability. The deep ocean doesn't rush because it doesn't have to. The processes that sustain it are older and steadier than anything on land. Sound behaves differently here too. It travels faster, carried by the dense water, but loses clarity. Everything is muffled, warped. A single knock or ping can echo for miles, folding and stretching as it moves. Some of the sounds that do exist are natural, the occasional creak of shifting rock, the distant rumble of a submarine landslide, or the faint, continuous hiss of tiny organisms moving in the water. If you were to listen carefully, you might detect low-frequency vibrations generated by the movement of tectonic plates. They're too deep for human hearing, but instruments record them as a slow, endless hum. It's like the planet itself is breathing in slow motion, exhaling through the trenches of the sea. The Emden Deep, lying at the far end of the Philippine Trench, is one of the deepest points in this vast underworld. Here, the water column stretches down more than 10 kilometres, and at the bottom lies a landscape that no sunlight has ever touched. The floor is not flat but uneven, shaped by landslides, sediment flows and tectonic deformation. Mud and fine silt have settled into soft layers, interrupted by rocky outcrops where the Earth's crust bends under unimaginable stress. The occasional seismic tremor ripples through, rearranging the terrain, though to anything living here it's just another slow pulse in the background. If you could walk on that sea floor, an impossible thought, you'd leave no footprints. The sediment is so fine and the gravity so weak compared to the weight above that it behaves almost like powder suspended in air. And yet, despite the darkness, despite the cold, despite the crushing force, life has found its way into every corner. Some of it is microscopic. Bacteria that feed on chemicals seeping from the crust, transforming minerals into energy through a process called chemosynthesis. Others are larger but no less strange. Amphipods, small crustaceans with translucent shells, sea cucumbers with transparent bodies, worms that glow faintly in shades of blue. These organisms don't just survive here, they thrive. Their metabolisms are perfectly tuned to scarcity. Some species can go weeks or months between meals, others recycle nutrients from decaying matter that would be useless to anything else. In the Emden Deep, nothing is wasted. Every particle of carbon, every molecule of energy eventually becomes part of something else. Exploring this darkness, researchers often describe a sense of contradiction. On one hand, the environment feels hostile, uninviting and alien. On the other, it's peaceful. There are no storms, no predators rushing in flashes of violence, no sudden changes. Everything happens slowly, predictably. The creatures here move with the calm assurance of beings that have never known another pace. When a deep-sea fish swims, it's not a burst of motion but a measured glide. When a shrimp feeds, it does so methodically, one slow bite at a time. The rhythm of life matches the rhythm of the sea itself. Steady, quiet, and enduring. The absence of light creates not just physical challenges but biological opportunity. On the surface, life is ruled by visibility. Who can see? Who can be seen? Who can hide? Down here, with no light at all, those rules vanish. Instead, evolution focuses on efficiency. Many deep-sea creatures have dispensed with eyes entirely, relying instead on sensitive hairs, pressure sensors, and chemical detection. Others generate their own light not to see but to communicate. Bioluminescence, so common in the twilight zone above, takes on new roles here. Some species emit a faint, constant glow, perhaps as camouflage against predators using bioluminescence themselves. Others release bursts of light when threatened, a flash that startles attackers just long enough to escape. There are also mating displays, brief exchanges of coded light patterns that help animals find each other in the vast dark. It's a system of signals invisible to almost every other creature on Earth. To humans, these glimpses of light are both eerie and beautiful. A remotely operated vehicle descending into the abyss might capture tiny pinpricks of blue, moving through the camera's field, drifting slowly like sparks in a black wind. For a moment, the darkness seems alive, and then the lights fade, and all that remains is the steady beam of the submersible's lamp cutting through an endless void. It's in moments like these that explorers say the ocean begins to feel infinite, as though it has no boundaries at all. You can look in any direction and see nothing, yet feel the presence of everything. The paradox is unsettling at first, but after a while it becomes oddly comforting. The deep sea doesn't care who's watching. It has existed long before we arrived and will continue long after we're gone. Because there is no day or night here, the usual cycles of behaviour vanish too. On the surface, animals rise and rest in rhythm with the sun. In the deep, those rhythms are replaced by patterns of opportunity. Some species migrate vertically, moving upward at night to feed on plankton that descend from the surface, then retreating back to the safety of darkness by day. Others remain stationary, anchored to the seafloor or drifting slowly in perpetual suspension. Their sense of time, if one can call it that, is tied not to light, but to the faint changes in current, the arrival of food or chemical signals in the water. For them, time is not a clock but a condition. If you consider how long these ecosystems have existed, it becomes clear that the deep sea operates on a timeline entirely separate from our own. The species living here today may be descendants of organisms that adapted to the deep billions of years ago. Their evolution has been slow, guided more by stability than by competition. That slowness might be their greatest strength. While surface species face constant change, temperature shifts, seasons, predators, the deep remains almost constant. It's a refuge from volatility, a domain of consistency. And yet, even here, change is coming. Human activity reaches farther than we often realise. Microscopic plastic fibres have been found in sediments collected from trenches like this one. Even here, 10 kilometres down, traces of our world drift in on the marine snow. The realisation unsettles scientists. The deep sea was once thought to be a perfect isolation chamber, protected by depth and remoteness. But as it turns out, no place on Earth is completely untouched. The Emden Deep, the last unexplored abyss, is not entirely pure. It too receives the faint signature of the surface world, the invisible footprint of civilization. It's a quiet reminder that our actions ripple farther than we can imagine. Still, there's something profoundly humbling about the fact that despite all our influence, the deep remains largely beyond us. We can send probes, we can measure and map, but we can't inhabit it. It doesn't yield easily to study. Every descent into its depths feels temporary, fragile, conditional. The pressure makes long-term human presence impossible, and technology still struggles to survive for extended periods. Even the best submersibles and remote vehicles are limited by power, communication, and endurance. That limitation isn't failure, it's perspective. The ocean reminds us that not everything exists to be conquered or lived within. Some places are meant only to be visited, observed briefly and remembered. When explorers return from dives to places like the Emden Deep, they often describe an unexpected emotion. Not excitement, not fear, but calm. After hours or days surrounded by darkness and silence, the noise of the surface world feels overwhelming. It's as if the deep teaches a slower pace, a kind of patience that lingers long after the dive ends. You realise that existence doesn't always need light or noise to have meaning. Sometimes continuity itself is enough. The deep ocean has been here for billions of years, evolving quietly while life on land rose and fell. It's the planet's most enduring environment, a reminder that stability, not change, is what defines most of Earth's history. The creatures that live here embody that lesson. They are living fossils in the truest sense, survivors of ancient lineages that have barely altered across epochs. The snailfish, for example, one of the deepest living vertebrates ever recorded, has been found near the floors of several trenches, including ones not far from the Emden. Its body is soft, translucent, and almost featureless, yet perfectly adapted. It can withstand pressures that would crush steel, all without armour or strength, just flexibility. That idea, that survival can come from softness rather than force, feels quietly profound. The deep sea doesn't reward aggression or speed. It rewards endurance and adaptability. The deeper you think about that, the clearer it becomes that this world without day or night isn't lifeless, it's balanced. Every organism here plays a role in recycling, transforming, and sustaining the cycle that began with sunlight far above. It's a vast machine of patience, operating on a scale that defies human urgency. Every fragment of matter that falls, every bacterial reaction, every subtle shift of current contributes to a continuous process that has kept Earth's biosphere stable for eons. To look at the deep is to look at the planet's core function, the quiet maintenance of balance that makes everything else possible. If you were to linger here long enough, watching the faint movement of silt and the soft glimmer of bioluminescent life, you might start to forget what surface life feels like. Time becomes elastic. Minutes, hours, and days lose meaning because nothing external marks their passage. You begin to understand why the deep ocean has always fascinated thinkers and artists. It's not just the mystery of what's hidden there. It's what the darkness does to your sense of scale and meaning. It strips away all distractions until only essentials remain: pressure, movement, survival, and silence. Somewhere far above, waves are breaking, ships are moving, clouds are shifting in the wind. None of that matters here. Down here, the only rhythm is the pulse of the earth itself, steady and ancient. You could stay for hours or centuries and the scene would barely change. That constancy might seem empty at first, but it's not. It's the foundation on which all the restless life above depends. Without this slow, dark equilibrium, there would be no oceans as we know them, no weather, no breathable atmosphere. Everything begins and ends in silence. The world without day or night stretches in every direction, immeasurable and indifferent, and somewhere beyond the reach of even the strongest submersible lies the bottom of the Emden Deep. It waits in that stillness, unseen but certain, holding stories written in silt and chemistry rather than words or light. The journey continues downward, and though the darkness deepens, understanding grows with it. Each meter of descent brings us closer to the boundary between the known and the unknowable, between what we can study and what we can only imagine. The pressure increases, the sensors record steadily, and ahead lies a place where the ocean meets the limits of exploration itself. Somewhere beyond this field of black water, beyond the last drifting plankton and faint glimmers of bioluminescence, the abyss begins to take its true form. Somewhere below the layer where all light dies, the ocean floor rises and falls like a frozen landscape. The darkness becomes not just a lack of light, but a presence of its own, thick, absolute, and constant. In that darkness lies the Emden Deep, a name that few have heard and fewer have spoken aloud, though it represents one of the most extreme points on Earth. It isn't a place that welcomes imagination easily, because the human mind struggles to picture depth on this scale. We can measure it, we can record it, but to feel it, to truly comprehend it, requires leaving behind every familiar reference. You don't look at the Emden Deep, you descend into it, one careful meter at a time, until the idea of surface and sky no longer matters. The Emden Deep sits at the southern end of the Philippine Trench, a vast gash in the seafloor that stretches more than 1,000 kilometers in length. This trench is part of a larger network of scars that circle the Pacific Ocean like the seams on a baseball. Each one marks the collision of tectonic plates, where the dense crust of the ocean floor sinks beneath lighter continental crust. In the case of the Philippine Trench, the Philippine Sea Plate is being forced beneath the Sunda Plate at a rate of several centimetres a year. That motion sounds slow, but across geological time it's relentless, carving a depression more than 10 kilometres deep and several hundred kilometres wide. It's not a static structure. It's alive in the geological sense, shifting, grinding, deforming, reshaping itself through earthquakes and landslides. Every few decades, part of the trench floor moves, sending tremors that can be felt hundreds of kilometres away. For centuries, no one knew the Emden Deep existed. Even when ships began mapping the ocean in the late 19th century, the focus remained on shallower waters closer to trade routes. It wasn't until the 20th century that sonar mapping revealed just how complex the ocean floor was. One of those early expeditions, conducted by German researchers, recorded an unusually deep echo in the southern Philippine Trench. They named the point after the ship that detected it, the Emden. It was a modest name for a discovery that hinted at something immense. Decades passed before anyone tried to confirm the measurement, and even then, results varied. Some surveys placed it at 10,400 metres, others at 10,540, still others slightly deeper. The numbers shifted with each generation of instruments, but all agreed on one thing. The Emden Deep was among the deepest places on the planet, rivaled only by a few other sites: the Challenger Deep in the Mariana Trench, the Horizon Deep in Tonga, and the Factorian Deep near Kermadec. When you look at a map of the Pacific Ocean floor, the Emden Deep doesn't stand out immediately. It's overshadowed by the Mariana Trench, which holds the record for the deepest known point on Earth. The Emden is less famous, quieter, its name rarely appearing in textbooks or documentaries, but that anonymity makes it even more intriguing. It's the quiet neighbour to the celebrity of the Mariana, a place that never sought attention but holds mysteries just as profound. Scientists sometimes call it the Forgotten Deep. Others prefer to describe it as the last frontier of the Pacific. Either way, it occupies a unique place in the geography of the ocean, a deep that seems to have waited patiently for us to notice. The Emden Deep's shape is not simple. From above, it looks like a narrow groove carved into the seabed, but in 3 dimensions it resembles a crescent-shaped valley, surrounded by steep walls that rise thousands of metres from the trench floor. These slopes are covered in sediment that slides downward in slow-motion avalanches. When earthquakes strike the region, those sediments can shift violently, creating underwater landslides that roll across the abyssal plain like invisible waves of mud. Each slide buries what came before, preserving layers of geological history under new blankets of sediment. In some places, those layers are more than a kilometre thick, a compressed archive of millions of years of Earth-shifting climate, volcanic eruptions and biological evolution. If you could hover above the Emden Deep with an impossible kind of sight, the scale would defy logic. The trench is so deep that Mount Everest, placed inside it, would still sit nearly 2 kilometres below the ocean surface. The pressure there reaches more than 100 times that of the atmosphere. To put it another way, every square centimetre of any object resting on the bottom experiences a weight equivalent to the full mass of a small car. For humans, such pressure would be instantly fatal. For machines, it's a constant test of design and endurance. Every expedition that has tried to explore the Emden Deep has faced the same challenge: how to survive the crushing force long enough to record what's there. One of the earliest modern efforts to reach the Emden Deep came from Japanese oceanographers using robotic submersibles in the early 2000s. Their goal was simple: map the trench in detail and measure its depth accurately. They succeeded in part, recording new data that placed the deepest point at just over 10,540 metres. But the footage they captured was limited. The darkness, combined with technical limitations, reduced visibility to a few metres at most. What the cameras did show was haunting. Fine sediments drifting like dust in still air, occasional shapes that hinted at life, and long, slow ripples across the mud that suggested movement of the earth itself. It wasn't much, but it confirmed that even here, in one of the most hostile environments imaginable, the planet was still active and alive. A few years later, another expedition returned, this time with improved technology. Remotely operated vehicles equipped with high-definition cameras and manipulator arms descended into the trench. They collected samples of sediment, small stones, and bits of organic matter. When the samples were brought to the surface, scientists discovered traces of microorganisms, living bacteria adapted to survive in the near-freezing, high-pressure conditions of the deep. These were not remnants of life washed down from above, but active colonies thriving in the sediment itself. That discovery changed how researchers thought about the Hadal Zone, the deepest region of the ocean. It proved that even in the most extreme environments on Earth, life finds a way to persist. It's easy to imagine the Emden Deep as empty, but the reality is far more complex. Each layer of its ecosystem supports another, forming a fragile chain that connects microscopic life to larger organisms. Amphipods, small crustaceans resembling shrimp, have been collected from nearby trenches and likely inhabit this one as well. These creatures feed on organic particles drifting down from the surface, their bodies adapted to withstand enormous pressure. Some species have transparent shells that allow gases to compress without rupturing. Others have biochemical adaptations that prevent their cells from freezing. When scientists examined their tissues, they found high concentrations of a compound called trimethylamine N-oxide, or TMAO, which helps proteins maintain structure under extreme conditions. It's the same compound that gives fish their characteristic smell, a faint reminder of the connection between surface life and the depths. Occasionally, researchers recover objects that don't belong, bits of plastic, fragments of fishing gear, or microscopic fibres woven into sediment layers. These traces of humanity travel thousands of kilometres from coasts and rivers before settling at the bottom. Finding them here, 10 kilometres below the surface, feels almost symbolic. It's a message written in debris saying that nowhere on Earth is truly untouched. Yet, despite that intrusion, the Emden Deep retains its mystery. The scale of it dwarfs human presence. A single plastic fragment lying on its floor is like a grain of sand in the Sahara. Understanding the Emden Deep isn't just a matter of curiosity. Trenches like this one play a vital role in the planet's systems. They act as gateways where the Earth's crust is recycled. The oceanic plate descending beneath the continental plate carries sediments, water, and organic material into the mantle. That process, subduction, drives volcanic activity, influences ocean chemistry, and shapes continents. The Emden Deep is part of that mechanism, one gear in the vast engine of planetary renewal. Studying it helps scientists understand how heat and material move through Earth's interior and how those movements affect everything from earthquakes to the carbon cycle. It's strange to think of a trench as a living process, but in a sense, it is. The floor of the Emden Deep is constantly shifting, however slowly as new sediments arrive and old ones sink deeper. The bacteria that inhabit it are part of that movement, breaking down matter, releasing gases, and influencing the chemistry of the surrounding water. Every reaction, every exchange contributes to a balance that keeps the ocean stable. When researchers take samples from these depths, they're not just collecting dirt, they're retrieving data about how the planet breathes. Despite its importance, the Emden Deep remains one of the least explored regions on Earth. Only a handful of dives have reached its lower slopes, and even fewer have touched the bottom. The reasons are partly practical. Deep-sea exploration is expensive, risky, and time-consuming. Building equipment that can survive the descent and return intact costs millions. A single malfunction can end an entire mission. The trench's remote location adds to the difficulty. Situated in the Western Pacific, far from major research bases, it requires days of travel just to reach by ship. Weather conditions can delay launches for weeks. Even when the ocean is calm, surface currents and waves complicate deployment. Every descent must be planned with precision, every component tested and monitored. Those who have studied the Emden Deep often describe a peculiar attachment to it, a kind of quiet respect that grows with each attempt to understand it. It's not dramatic like a volcano or visible like a glacier. It doesn't announce itself. It hides. And perhaps that's why it captivates the few who dedicate their lives to mapping it. when you stare at sonar data for weeks and finally see a faint outline emerge, a slope, a ridge, a depression, you're glimpsing a place no one has ever seen directly. The thrill isn't in the danger or the fame, but in the intimacy of discovery, in knowing that you're witnessing something new about the Earth itself. If you stand on the deck of a research vessel above the Emden Deep, the ocean looks no different than anywhere else. The surface rolls gently, the horizon remains flat, and the sky reflects off the water in endless patterns of blue. There's nothing to indicate that beneath you lies a chasm deeper than any mountain is tall. That's one of the ocean's quietest tricks. It hides its vastness in plain sight. The greatest extremes of our planet are invisible, cloaked under kilometres of ordinary-looking sea. Somewhere below that calm surface, instruments hum, cables descend, and machines move slowly downward toward a world that would crush them without mercy if they failed. When those machines reach the bottom and their cameras switch on, the first thing they often record is sediment falling like snow. It never stops. Each grain drifts downward for days, sometimes weeks before settling. Together, they form a constant rain of time, everything that lived and died above becoming part of the deep. In some ways, the Emden Deep is not just the lowest point of the ocean, but also its final resting place. It collects the planet's history grain by grain, decade after decade, until the seabed becomes a record of everything that has ever existed above it. It's tempting to call that tragic, but it's not. The ocean doesn't mourn, it recycles. What falls here feeds new life, sparks new reactions, continues the cycle. The deep isn't a graveyard, it's a factory of beginnings. The bacteria that live in its sediments break down organic matter into forms that will one day rise again through vents or currents, nourishing life elsewhere. The Emden Deep isn't the end of anything, it's one more step in the endless transformation of Earth's materials from one form to another. Thinking of it that way changes the sense of what deep means. Depth isn't just distance downward, it's connection. The Emden Deep links the surface to the mantle, the living to the geological, the present to the ancient. Each layer of pressure and darkness ties us to the planet's structure more intimately than any mountain peak could. When explorers talk about reaching the bottom, they're really talking about tracing a path through the story of the Earth itself, from sunlight to silence, from movement to stillness. Someday, perhaps soon, new expeditions will return with better technology, robots capable of mapping the floor in high resolution, sensors that can analyze chemical reactions in real time, instruments that can detect the faintest signals of life. When they do, the Emden Deep will finally begin to reveal itself in detail. But even then, it will retain its mystery, because no matter how clear the images or how precise the data, there will always remain something unknowable about a place that has existed so long without witnesses. That unknowability isn't a failure of science, it's part of the deep's identity. The abyss keeps some of its secrets, not out of malice, but because mystery is built into its nature. Above, the ocean continues its slow motion, unaware of the attention from the surface. Waves rise, wind passes, clouds shift. Below, in the stillness of the trench, the Earth moves at a pace of its own, reshaping the crust, feeding its interior, sustaining invisible life. The Emden Deep has a name, but naming something doesn't mean we own it or even understand it. It only means we've acknowledged its existence. The rest remains to be learned. One descent, one fragile machine, one faint echo at a time. And somewhere in that darkness, where pressure and silence merge into one, the story of this hidden abyss continues, waiting patiently for the next signal from above, for the next attempt to listen to what the Earth still has to say. The deeper the descent continues, the more silence becomes something tangible. It is no longer the absence of sound, but a kind of density that fills every space. When the ocean grows this deep, the usual noises of the world are gone. There are no waves breaking, no distant engines, no wind against the hull of a ship. Even the mechanical hum of a submersible feels muffled, absorbed by water that seems to swallow vibration before it can travel. You can speak, but your words reach only as far as your helmet or the microphone attached to it. Beyond that, they vanish into the weight of silence that defines the abyss. At 10 kilometers below the surface, the pressure is almost impossible to describe in familiar terms. Every square inch of any exposed surface endures more than 1,000 times the weight of the air above sea level. Steel thick enough to support bridges would fold here like paper. Glass, even tempered and reinforced, would shatter before it reached half this depth. Machines built for the Emden deep must be crafted with absolute precision. Their shells are spheres, the only shape that can evenly distribute the crushing force around them. Titanium and specialized synthetics are used not for luxury but for survival. One imperfection, one unnoticed flaw, and the ocean would press inward with unstoppable speed, reducing everything inside to fragments in a fraction of a second. The silence that reigns here is not absolute, but it feels that way. There are sounds, if you have the right instruments to detect them. The groaning of tectonic plates moving far below, the faint crackle of sediment shifting under its own weight. The occasional tremor when part of the trench wall gives way, sending cascades of mud and rock into the abyss. But these noises are not like those on the surface. They have no direction. They don't echo or carry. They appear and fade as if the water itself is thinking. The stillness between them feels heavier than the sounds themselves, a presence more than a pause. Explorers who have reached depths like this describe an odd psychological reaction to the quiet. At first it feels peaceful, then it begins to feel too complete, as though something essential to being human is missing. We are creatures accustomed to noise, footsteps, speech, the rustle of wind, the subtle hum of electricity. Down here, stripped of all that, the mind starts to reach for something to fill the void. Some people report hearing phantom sounds, whispers, mechanical echoes, even the faint rhythm of a heartbeat that isn't their own. The brain invents noise to protect itself from the absolute stillness. It's not madness, it's adaptation. In a place where silence is as dense as the water itself, the mind tries to stay afloat. For the life that endures here, silence is normal. Communication doesn't rely on sound but on chemical cues, on the faint exchange of light or vibration. Certain amphipods can detect movement from meters away through changes in pressure. Some worms release pheromones into the water, invisible trails that others of their kind follow. There are creatures that glow when they collide, creating brief sparks that might serve as warnings or as calls for company. None of this is loud, none of it abrupt. It's a system built for patience, where meaning travels slowly, and distance is measured not in space, but in delay. The pressure shapes everything in this environment. It determines how bodies are built, how cells function, even how molecules behave. At sea level, chemical reactions happen in open space, molecules colliding and separating freely. Down here, space itself is compressed. Molecules are forced into proximity, bonds form differently, and structures that would be unstable above become permanent. It's not just biology that adapts, it's chemistry. The ocean at this depth is less like water and more like a living medium, one that alters everything that enters it. The silence, the pressure, the darkness, they are all expressions of the same force, the weight of the planet pressing inward. Every mechanical expedition to the Emden Deep must contend with that force. A typical descent takes several hours, each minute adding another layer of tension as the pressure increases. The engineers who design deep-sea submersibles understand that every bolt, every weld, every seal is part of a delicate contract between physics and endurance. There is no room for error. During the descent, temperature drops steadily until it stabilizes just above freezing. The hull creaks as the outside force compresses it. Inside, air pressure remains normal, creating the strange sensation of being safe in a fragile bubble surrounded by lethal density. It's a reminder of how thin the barrier is between human life and the overwhelming power of nature. When the craft finally settles on the seafloor, the stillness is complete. The pilot might switch off the thrusters, and in that moment the hum of machinery fades. The only remaining sound is the faint ping of sonar, a slow heartbeat used to navigate through the blackness. The external lights reveal the landscape in narrow cones. What they show is not chaos but simplicity. Smooth plains of sediment, occasional ridges of rock, and drifting clouds of silt disturbed by the descent. There is no turbulence, no movement beyond what the pilot creates. The silence presses in from all sides, a sensation as physical as the pressure itself. It's in these conditions that the smallest noises become monumental. The click of a camera shutter sounds like thunder. The vibration of an arm extending to collect a sample feels enormous. The release of ballast weights at the end of the mission echoes through the hull like a drumbeat. Silence gives every action weight. You become aware of sound as a presence, not an afterthought. Some pilots describe the experience as meditative, others as suffocating. Both are true, depending on the moment. The silence is not lifelessness. If you let your instruments adjust and wait long enough, you begin to see movement in the sediment. Tiny organisms crawl through it, stirring up faint clouds of dust. Their motions are slow but constant, a kind of quiet work that continues day and night. Microbes thrive in these sediments, feeding on organic matter that drifts down from the surface. Their metabolism is sluggish but efficient. They process compounds that would be toxic to most life, ammonia, methane, hydrogen sulfide, and turn them into energy. Each cell functions under pressures that would crush anything unprepared. To them, the weight of silence is not oppressive, it's normal. In a way, these microbes are the true inhabitants of the deep. They outnumber every other form of life, occupying every pore of the sediment and every droplet of water. They have no eyes, no need for sound, no sense of isolation. They exist entirely in the moment, each one contributing to a system that has no hierarchy, no urgency, and no awareness of being observed. Their activity releases gases that rise slowly through the water, feeding other microorganisms along the way. Even the silence contributes to the balance, because it allows stability. No sudden changes, no shocks, just the slow continuation of life beneath the crushing calm. When samples of this sediment reach the surface, scientists handle them with care, not just because of their fragility, but because they represent a world that collapses outside its own environment. Once removed from the pressure, many deep-sea organisms simply fall apart. Their cells rupture, their structures dissolve. They are creatures of weight, their biology dependent on the force that confines them. To study them, researchers must recreate those pressures in laboratories, building small chambers that simulate the deep. It's an imperfect process, but it reveals enough to understand that life here is not accidental, it's deliberate. Evolution has written a code specifically for silence and weight. Pressure doesn't just influence life, it also shapes the geology of the trench. The rocks at the bottom are compressed and fractured, forming a crust denser than anywhere else on the planet. Chemical reactions between seawater and the minerals of the crust create new compounds that may hold clues to the origins of life itself. Some scientists believe that under similar conditions billions of years ago, organic molecules first assembled into living cells. The deep ocean, they suggest, is not just a frontier but a memory. It carries the conditions that may have birthed everything we know. The silence here is older than sound. It has existed since the earth cooled and oceans formed. For billions of years it has endured, changing only in detail but never in essence. When volcanic eruptions reshaped continents, when ice ages advanced and retreated, when species rose and vanished, this deep silence remained. It's the baseline of the planet, the constant beneath all noise and motion. Listening to it is like hearing the background hum of existence. Above, sound defines life. We speak, we move, we listen. We measure time in beats and steps. Down here, time is measured in stillness. The absence of sound doesn't mean nothing happens. It means everything happens slowly enough that it doesn't need to be heard. Sediment settles at a rate of millimeters per 1,000 years. Geological shifts occur over centuries. Life cycles unfold at speeds that make decades look like moments. Silence, in this sense, is the sound of time stretched beyond recognition. There's an argument to be made that silence is essential to understanding the deep ocean. Without it, the data collected would be meaningless. Every instrument depends on the quiet to detect faint signals. The echo of sonar, the vibration of a chemical reaction, the movement of microscopic life. If the ocean were noisy, the Emden Deep would be invisible. Its identity is written in stillness. Each recording made here, each line of data, is a translation of that quiet into numbers and graphs. Scientists listen for silence as much as they listen for sound. The absence of disturbance tells them as much as any signal. When human technology enters this world, it brings with it an uninvited kind of noise. The low hum of motors, the whine of hydraulic arms, the high-pitched sonar pings, all foreign to this environment. Even a single descent disturbs the peace in ways that last for hours. Silt stirred by a passing submersible can take days to resettle. Some scientists worry that the growing interest in deep-sea mining and exploration could introduce permanent noise into these regions, altering the ecosystem before we even understand it. The silence is fragile. It exists not just because the deep is remote, but because it has never needed to be otherwise. If you could stand outside the submersible for even a moment, which of course you cannot, you'd experience the silence not as a sound but as pressure on your body. It would envelop you, fill you, erase the distinction between inside and out. The weight of the water would become indistinguishable from your own heartbeat. That's what silence means here. Complete immersion in the physical presence of the ocean. It's not something you hear, it's something you become part of. There's a certain humility that comes with realizing that the deepest parts of the ocean don't need us. They've existed perfectly well without observation, without recognition. When we leave, the silence closes back over like an untouched surface. No trace remains of the descent except a few lines of data and perhaps a few disturbed grains of silt. The trench resets itself instantly. That kind of resilience is difficult to comprehend for a species used to leaving footprints everywhere it goes. To most people, silence is temporary, an intermission between sounds. In the Emden Deep, it's the default state. The surface is the exception, the noisy, chaotic layer where things happen too fast to last. Down here, permanence replaces urgency. The weight of silence holds everything steady. It presses down not to destroy but to maintain. Every particle is in its place, every movement absorbed and balanced. It's not still because nothing happens. It's still because everything that happens is already accounted for. When explorers finally ascend, when the submersible rises slowly through kilometers of water, the first new sound they hear is their own breathing. Then the hum of machinery, the faint crackle of the radio reconnecting, the distant slap of waves at the surface. After hours in the deep, those sounds feel overwhelming. They're reminders of the world waiting above, the fragile, noisy, temporary world that forgets what silence means. And somewhere below, long after the last light fades and the pressure closes in again, the Emden Deep remains as it always has, defined by the weight of its quiet. The silence of the trench is not absence but presence, not emptiness but fullness. It carries the memory of the earth, the balance of its systems, and the patience of time itself. Every journey into it is temporary, every discovery partial, but that doesn't diminish its meaning. The deep doesn't need to be fully known to be real. It exists beyond the limits of our comprehension, beyond language, beyond sound. the weight of silence continues, unchanged, holding the planet steady beneath the shifting noise of life above, and the descent goes on, deeper still, toward what waits beyond the reach of hearing and sight. For as long as people have looked out at the ocean, there has been an urge to go where sight fails. Every culture that lived beside the sea carried stories about what lay beneath it, most of them mixtures of fear and fascination. The first explorers of the deep weren't scientists or engineers. They were sailors, fishermen and pearl divers, people who learned early that the water below was more than a surface. They understood, without instruments, that the sea was layered, that each layer held its own moods and mysteries. When the first attempts to measure depth began, the idea of an abyss was still abstract. A line of rope weighted with lead told only that the bottom was far away. The numbers meant little without vision. It wasn't until the last century that humanity started to see for itself, and even then the vision was narrow, glimpses snatched through small windows in the dark. The Emden Deep became part of that long story of looking down. Its discovery came late, almost by accident, during an age when attention was focused elsewhere. The middle of the 20th century was a time of new ambition in oceanography. Nations were sending ships to map the seafloor, using sonar and magnetometers to trace the invisible contours of the world's oceans. The Cold War gave science new funding and new motives. Submarines needed safe routes. Navies wanted to understand how sound travelled underwater. Every trench and ridge became data. In the midst of that global mapping effort, the Emden Deep appeared as an anomaly, one of several points that defied earlier charts. A German research vessel recorded the echo in the 1920s, but it was not until decades later that anyone returned to confirm it. The record sat in archives, a curiosity named after the ship that found it, waiting for technology to catch up. When the technology finally arrived, the ocean responded with silence. Early sonar readings gave inconsistent results, and for years no one could agree exactly how deep the Emden point was. Instruments failed, cables snapped, signals returned garbled. It was as if the deep resisted being measured. The equipment would record depths of 10,000 meters one day, 10,600 the next, then less again. Some suspected instrument error. Others wondered if the seafloor itself was shifting. In a way, both were right. The Emden Deep is a living fault, part of an active subduction zone. It changes shape over decades, sometimes over days. What is measured once is never quite the same again. Every expedition must start over. In the early 1970s, Japanese oceanographic surveys revisited the region with more advanced sonar arrays. Their maps were the first to show the trench clearly, stretching like a scar parallel to the Philippine coast. The deepest part, near 10.5 kilometers, was labelled Emden Deep in small print on the chart. It was a technical note, not an announcement. No television cameras were present, no headlines written. It entered science quietly, as deep things tend to do. A few scientists published papers, a few more added it to global depth records, and then attention drifted elsewhere, to the Mariana Trench, which already held the world's record in the public's imagination. The Mariana had history. In 1960, the bathyscaphe Trieste had descended to its Challenger Deep, carrying Jacques Picard and Don Walsh into what was then the deepest dive ever achieved by humans. The Emden Deep, by contrast, remained unseen. No human eyes had looked upon it. No cameras had captured its floor. It existed as data points, not as experience. For the next half-century it lingered on the margins of exploration, visited only by the faint sonar echoes of survey ships. Then came the modern age of deep-diving machines. Advances in materials science, electronics and robotics transformed what was possible. Unmanned submersibles could now withstand pressures that would have destroyed earlier craft. The deep submergence vehicle Kaiko, built by the Japan Agency for Marine Earth Science and Technology, reached the Challenger Deep several times in the 1990s and early 2000s, recording footage and collecting samples. Similar vehicles mapped the Tonga, Kermadec, and Puerto Rico trenches. Gradually, attention returned to the Philippine Trench and its southernmost depression, the Emden. One of the first modern probes to visit it sent back images that surprised everyone. Instead of a barren plain, the cameras showed signs of life, small amphipods skimming over the sediment, translucent worms, delicate sea cucumbers drifting like ghosts over the mud. The sediment was fine as smoke, disturbed by the slow movement of the probe's thrusters. Everything moved in slow motion, every particle taking minutes to resettle. The operators on the ship above watched the footage in near silence. After decades of speculation, the Emden Deep was no longer theoretical. It was a real place, alive and intricate in its own quiet way. But as soon as those first pictures appeared, the challenges of working at such depths became clear. Communication between the probe and the surface was erratic. Data took seconds to transmit. A signal sent downward bounced and scattered, distorted by layers of water with different temperatures and densities. In the middle of one dive, the vehicle's manipulator arm jammed, locked by pressure that no human hand could release. The mission was aborted, and the vehicle was winched back slowly, taking hours to rise through the dark. By the time it reached the surface, its casing was dented, its electronics fried. The deep had taken its toll. The images survived, but the machine did not. It is easy to forget that exploration is often built on loss. For every successful descent, there are failures that never make the news. Cables snap, batteries fail, weather changes suddenly. Ships drift off station, forcing retrieval before missions are complete. Even the best-planned expeditions rely on luck as much as skill. The Emden Deep, remote and temperamental, magnifies every risk. Storms in the Philippine Sea can appear with little warning. Typhoons form in the same waters, sometimes days after a launch. The crews who venture there plan for weeks, study weather models, and still find themselves waiting, watching the sky for a break in the clouds. The ocean decides when the descent begins, not the clock. In recent years, a few private expeditions have joined the effort. The growth of commercial deep diving programs, led by individuals rather than governments, has opened new opportunities for exploration. The Emden Deep, being both deep and less publicised than the Mariana, became an appealing target for those seeking new records. In 2021, a team led by Victor Vescovo and Filipino scientist Dio Florence Onda conducted the first manned descent into the Emden Deep, using the submersible DSV limiting factor. They reached the bottom after more than 4 hours of descent. From inside the pressure sphere, they observed a flat plain of fine silt, small rocks, and occasional fragments of organic debris. The experience was described not as thrilling, but as sobering. In a place that few believed could be reached, 2 humans floated for several hours, their lights carving small circles in an endless darkness. The images from that descent were clear but stark. The bottom looked almost featureless, broken only by faint ridges and depressions. Occasionally a small amphipod darted across the camera's view. There was movement, but no noise, no drama. When the explorers spoke later about what they saw, they used words like still, overwhelming, and humbling. It was not a world that rewarded curiosity with spectacle. It rewarded it with perspective. The ocean had given them a view of its emptiest place, and even there, they found traces of life. Perhaps that is why the Emden Deep holds a certain pull for those who study it. It is not famous, not glamorous. It is difficult to reach, and even more difficult to describe. Yet it stands as proof that exploration is not about excitement, but endurance. Each visit adds a fragment of knowledge, a few minutes of footage, a few grams of sediment. These small accumulations form the story of our relationship with the deep. They show how far human persistence can reach when driven by curiosity alone. When researchers analyse samples from the Emden Deep, they find more than biology. They find traces of our own history embedded in the mud. Tiny particles of soot from industrial activity. microscopic fibres from clothing, even isotopes from nuclear tests conducted decades ago. These remnants have drifted downward for years, carried by currents and gravity, eventually settling in the lowest places on Earth. The trench floor becomes an archive not only of natural processes but of human presence. Every layer of sediment tells a story: the rise of industry, the spread of plastics, the fallout of atomic age ambition. The deep remembers even when we forget. Explorers often speak of ghosts when they describe their time underwater. They don't mean spirits, but memories, echoes of those who came before and those who might never return. Every descent into the deep carries a shadow of risk. Equipment can fail, weather can change, and rescue is almost impossible. The ocean is indifferent to human persistence. When a submersible descends, it leaves the living world behind in a literal sense. Above the surface, radios connect crews, computers log data, voices call across decks. Below a few hundred meters, the connection weakens. By the time the craft passes 2,000 meters, conversation has turned into static. By 4,000, it's reduced to coded pings. The deeper it goes, the more isolated it becomes, until the link to the surface is as faint as a heartbeat in a dream. To descend into that isolation is to experience a kind of communication with the past, an understanding shared by all explorers who have ventured into places where help cannot follow. Some who return from such dives describe a strange change in perception afterward. For weeks, sometimes months, the world feels too loud, too bright, too quick. They find themselves longing for the measured pace of descent, for the slow passage of time inside the sphere, for the rhythm of sonar pings echoing through the dark. It's not nostalgia so much as adjustment. When you've spent hours surrounded by the weight of silence, the noise of the surface feels almost alien. That reaction is universal among deep-sea divers and astronauts alike. Both know the sensation of being enclosed, isolated, and at the mercy of systems that must not fail. The difference is direction. One looks down, the other up. Both confront the same emptiness and the same understanding that exploration is an act of trust, not in courage but in design. The ghosts of exploration are also the machines themselves. Many of them still rest on the seafloor, lost to mechanical failure or human error. They lie scattered across the world's trenches, probes, cameras, sensors, silent reminders of attempts that went too deep or lasted too long. Somewhere near the slopes of the Philippine Trench, a Japanese submersible that malfunctioned decades ago still sits buried in sediment. Its frame is corroded, its electronics dead, but its shape remains. Over time, small organisms have colonized it. It has become part of the landscape it once came to study. In that way, even failed missions contribute to the deep's ecology. The ocean accepts everything eventually. Each new descent builds upon those losses. Engineers design stronger hulls, more efficient thrusters, better materials. Pilots learn to read the small shifts in pressure and movement that signal when a vehicle is struggling. Data from past failures inform future safety. The ghosts become teachers, their silence turned into knowledge. This is how exploration progresses, not through triumph, but through the slow accumulation of understanding bought at high cost. What lingers most about these descents is not the footage or the samples, but the awareness of scale. Standing on the deck of a ship afterward, looking down at the calm surface, it's difficult to reconcile what lies beneath. The distance between the surface and the bottom is nearly the same as that between the ground and the cruising altitude of a jet, yet that space, filled entirely with water, remains unseen by nearly everyone who has ever lived. The Emden Deep reminds humanity that our planet's greatest unknowns are not far away. They're directly below us, hidden under something as ordinary as the sea. In this sense, every explorer who ventures downward becomes a kind of ghost themselves. They pass temporarily into a world that resists the living, that demands surrender to conditions no body can withstand for long. When they rise again, they carry something intangible, an awareness of the fragility of their existence and the vastness of the world that supports it. They return changed, though the surface looks the same. That change ripples outward, shaping how we think about our planet and our place in it. The Emden Deep continues to attract those willing to face that transformation. There will always be new expeditions, new machines, new data. Some will fail, some will succeed, but the essence will remain the same, a quiet pursuit of understanding through patience and precision. The deep does not yield easily. It offers no guarantees, no comforts, no applause. It gives only silence, pressure, and truth. And those who venture there carry that truth back with them, adding another line to the long story of human curiosity. Far above, waves still move in rhythm with the wind. Ships cross the surface without noticing what lies beneath their roots. But in the darkness below, the ghosts of exploration drift, their presence recorded in the instruments and memories of those who followed. The Emden Deep waits, unchanged, patient as always, its silence holding everything that has ever tried to know it. The story does not end there, because exploration never does. The ocean has more to show, more to test, more to reveal, and beneath the weight of its silence the descent continues, steady and unending, toward life that endures where no one expected it to exist. If you were to take the light of day and compress it into a single point, then watch it fade until nothing remained but the slow movement of darkness, you would be somewhere close to where life still exists at the bottom of the Emden Deep. What happens here shouldn't happen at all. By every measure known to surface biology, this environment is impossible. The pressure alone should crush the delicate membranes of cells. The cold should freeze metabolism to a halt. The lack of sunlight should make photosynthesis, the foundation of almost all life on Earth, completely irrelevant. And yet, against all reason, life persists. It doesn't just survive, it operates with a quiet precision that makes adaptation look less like struggle and more like instinct. The first question most people ask is how? How does anything live in a place where the temperature barely rises above 2 degrees Celsius and the pressure is more than 1,000 atmospheres? The answer begins with chemistry. At the surface, life depends on energy from the sun, captured by plants and algae through photosynthesis. In the deep, light never arrives. Instead, energy comes from chemical reactions between water and minerals in the seabed. This process, known as chemosynthesis, uses compounds like hydrogen sulfide, methane, and ammonia to build organic molecules. Certain bacteria can harness these chemicals directly, turning what seems like waste into nourishment. They are the foundation of an ecosystem that owes nothing to sunlight and everything to the restless geology of the planet. At the Emden Deep, these bacteria form films on rocks and sediments, invisible to the eye but vital to everything else. They colonize microscopic cracks in the seafloor, thriving where minerals seep out from the crust. In some places, they gather into mats so dense they appear as faint pale layers when illuminated by artificial light. Small crustaceans feed on them, and larger creatures feed on those crustaceans. The food web is short, efficient, and tightly bound to the chemistry of its surroundings. Every organism here has evolved to use the smallest possible amount of energy, to waste nothing, and to endure long periods of scarcity without dying. Among the most remarkable inhabitants of the deep are amphipods, small shrimp-like creatures that seem to exist everywhere. Pressure is high, and light is absent. They look fragile, translucent, almost decorative, but their resilience is unmatched. Scientists have found them in nearly every Hadal trench on the planet, including the Emden. Some species grow larger than their shallow water relatives, a phenomenon known as deep-sea gigantism. The reasons are not entirely clear, but it may relate to the abundance of oxygen in cold water or the slow metabolism that allows growth over long lifespans. Amphipods feed on detritus, on the soft rain of organic material that drifts down from the upper ocean layers. When they encounter a larger carcass, perhaps a dead fish or a jelly that has sunk from above, they gather in swarms, consuming it with patient efficiency. Nothing is wasted, nothing left to rot for long. The bodies of these animals tell the story of pressure adaptation. Their cells contain molecules that prevent proteins from collapsing under compression. One of these molecules, TMO, increases in concentration with depth. Surface fish have little, deep-sea fish have a lot. The compound stabilizes their biochemistry, keeping membranes flexible and enzymes functional. But it also gives them a distinctive smell. The scent we associate with fish markets is, in part, the smell of a chemical that makes survival at depth possible. In that way, the deep leaves its mark even on what we eat without thinking. Not all life in the Emden deep moves. Some of it waits. Sea cucumbers, gelatinous animals related to starfish, lie on the sediment, feeding slowly by filtering particles from the water. Their bodies are soft, filled with fluid rather than muscle, allowing them to withstand the pressure without resistance. They move only when necessary, drifting with currents rather than swimming. Their survival strategy is patience, expend nothing, waste nothing, endure everything. Nearby polychaete worms burrow into the mud, invisible but active, turning the sediment as they feed. Each one leaves faint trails that look under camera light like writing on the seafloor. It's tempting to imagine it as language, but it's just the pattern of life continuing in a place where nothing should move at all. The bacteria that anchor this ecosystem are extraordinary, not just for where they live, but for what they endure. Some can survive pressures 20 times greater than those of the deepest trenches. Others have been shown to remain viable after exposure to radiation, freezing, and vacuum. They represent the most adaptable form of life we know. Organisms that ignore the boundaries we once thought defined habitability. Studying them has become a way of studying possibility itself. Astrobiologists look at the microbes of the Emden Deep and see analogues for life that might exist beneath the ice of Europa or Enceladus, moons with oceans hidden under kilometres of crust. The chemistry is different, but the principle is the same. Where there is energy and stability, life finds a foothold. The Emden Deep is a testing ground for that idea. Every sample of sediment retrieved from its bottom contains hints of complexity. DNA sequencing reveals networks of microorganisms interacting through chemical exchange, forming communities that regulate their environment just as surface ecosystems do. There are bacteria that feed on methane, others that oxidize sulfur, and still others that consume the waste of their neighbors. Together they form what scientists call a microbial loop, a closed circuit of energy flow that sustains itself indefinitely. In the absence of sunlight, life has become a system of internal recycling. It's not abundance that defines it, but balance. When researchers examine these communities in the lab, they often struggle to keep them alive. Many species die as soon as the pressure drops. Their cell membranes evolve to function under immense compression, rupture in normal atmospheric conditions. Even when pressure chambers are used, reproducing the precise chemistry of the deep ocean is difficult. The balance of gases, minerals, and temperature must be perfect. A small deviation, and the experiment collapses. For that reason, much of what we know about deep life comes from indirect evidence, genetic analysis, chemical signatures, and traces of metabolic byproducts. Even in the age of modern science, the deep remains largely inaccessible. We know it exists. We know it functions. We can describe it, but not yet truly experience it. Life at the bottom of the Emden Deep is not uniform. The trench's walls and floor create microhabitats where conditions differ subtly. Some slopes receive more sediment from landslides, burying life temporarily before new organisms recolonize the surface. Other areas remain stable for centuries, allowing slow-growing communities to establish. The distribution of species is patchy, influenced by currents, temperature, and the chemistry of the sediment. It's a mosaic of existence, constantly rearranged by forces too gradual for us to see. Over geological time, entire populations shift and evolve, leaving behind traces that become part of the sedimentary record. Each layer holds the remains of organisms that lived and died under pressures we can barely imagine. Occasionally, larger creatures visit the trench, descending from shallower depths. Some species of snailfish, for example, have been observed in nearby trenches and may inhabit parts of the Emden. They are translucent, almost formless, their bones replaced by cartilage, and their muscles soft as jelly. They move slowly, propelled by gentle undulations of their fins, conserving energy. Their skin is thin, their organs adapted to function without air-filled spaces that would collapse under pressure. Watching them on camera, it's difficult to tell where the fish ends and the water begins. They seem to dissolve into their surroundings, a perfect example of adaptation not as resistance, but as acceptance. These organisms don't compete in the way life does on the surface. The scarcity of resources makes aggression inefficient. Instead, coexistence dominates. Predation still happens, but rarely and without waste. A dead body becomes food for dozens of species, each taking a portion suited to its needs. The result is an ecosystem without hierarchy, where survival depends less on dominance and more on cooperation. It's a reminder that evolution is not a contest of strength, but a process of adjustment. The deep shows what happens when the pace of life slows enough for balance to emerge. The chemical exchanges that sustain this balance are subtle but powerful. Methane released from the seafloor is consumed by bacteria before it can reach the water column, preventing it from entering the atmosphere. Sulfides are oxidized and recycled. Even heavy metals bind with organic molecules, becoming less toxic. In this way, the deep ocean acts as a vast filtration system, a stabilizer for the planet. What happens in the Emden Deep affects, indirectly, the air we breathe. Yet this process is invisible, continuous, and largely unacknowledged. The stability of the world depends on ecosystems that most of humanity will never see. When we talk about life at the edge of existence, it's easy to imagine extremity as exception, but here it's the rule. The deep is not marginal, it's fundamental. More than half of the planet's biomass exists below 1,000 meters, much of it microbial. The Emden Deep is just one of countless sites where life operates under conditions that seem unlivable. It challenges our sense of what Earth is. The surface, where we live, is a thin veneer of light and warmth atop an ocean of darkness that sustains it quietly from below. If you were to look closely at a handful of sediment from the trench, you would see grains of mineral mixed with organic fragments. Under a microscope, each grain becomes a landscape. Tiny structures coated with bacterial films, filaments extending from cell to cell. In the slow rhythm of the deep, these cells divide, consume and die over timescales that make human lifespans irrelevant. Some colonies might persist for centuries, maintaining equilibrium in a few cubic centimeters of mud. This is life stripped of spectacle, existing purely for continuity. It's easy to overlook, but without it, the planet would lose its balance. The Emden Deep also holds secrets about the origin of life itself. The same conditions that make it hostile to us, pressure, heat, mineral interaction, may have been the catalyst for the first living systems billions of years ago. Laboratory simulations of hydrothermal vents and subduction zones have shown that under these pressures, simple molecules can combine into more complex forms, amino acids, lipids, even nucleotides. The trench may be one of the few remaining environments on Earth that still mirrors those early conditions. In that sense, studying its life is like looking backward through time, into the chemistry that once gave rise to biology. There's something humbling about the idea that the oldest forms of life still exist at the planet's deepest points. They've watched continents drift, climates shift, and species rise and fall, all while remaining unchanged. The same processes that sustain them now sustain their ancestors long before the first trees or animals appeared. In their simplicity, they carry the memory of the planet's earliest days. To observe them is to confront continuity on a scale that defies imagination. For all our technology, we can't replicate that continuity. Our presence in the deep is temporary, fragile, dependent on machines that must return to the surface within hours. Life here, by contrast, has adapted to permanence. It doesn't rise or fall. It endures. The amphipod crawling over the sediment today may be part of a lineage millions of years old. Its genetic code refined not by speed, but by stillness. It embodies a truth that's easy to forget at the surface. Existence doesn't always need motion to persist. When lights from a submersible sweep across the seafloor, the creatures that live there don't react with panic. Some drift aside slowly, others ignore it entirely. To them, this intrusion is brief, insignificant. They have no reason to fear what passes overhead. The light fades, the noise stops, and their world returns to its natural state. In the silence that follows, the sediment settles again, and the cycle continues. For the deep, every visit is just another moment in an unbroken continuity stretching back to the beginning of life on Earth. The Emden Deep's ecosystem, fragile though it appears, is also resilient. It can absorb disturbances, adapt to change, and recover over time. But that resilience has limits. The introduction of pollutants, even microscopic ones, alters the chemistry that life depends on. Plastic fibres, heavy metals, and industrial residues have already been found in trench sediments worldwide. They travel thousands of kilometres from land, descending slowly until they reach the bottom. Once there, they become part of the system, sometimes harmlessly, sometimes not. The long-term effects are still unknown. The deep is stable, but not invincible. Still, the fact that life continues here at all suggests that stability is stronger than fragility. The same forces that could destroy life also sustain it. Pressure, darkness, and cold become, in combination, the perfect environment for a certain kind of existence, one that doesn't seek to expand or conquer, only to persist. It's a lesson written in every cell of the organisms that live here. Their survival isn't an act of defiance, but of adaptation so complete it becomes indistinguishable from acceptance. When scientists speak about the Emden Deep, they often sound reverent. Not because it's dramatic or beautiful in the usual sense, but because it represents the edge of what life can be. It shows how thin the boundary is between possible and impossible. In a world defined by human ambition, where we measure success by expansion and speed, the deep reminds us that endurance can be just as powerful. The creatures that live here don't grow quickly or brightly, but they persist across ages, quietly maintaining the balance that allows everything above them to exist. And so the story continues, not in bursts of discovery, but in the slow accumulation of understanding. Each dive reveals a little more about how life endures where nothing should live. Each sample adds another detail to the map of existence at the edge. And while the rest of the world moves with haste, this world remains patient, steady, and timeless, holding the memory of Earth's beginnings within the quiet pressure of its depths. Every grain of sediment at the bottom of the Emden Deep carries a story older than memory. It drifts slowly through kilometres of water, gathering fragments from the surface world, dust from continents, ash from volcanoes, traces of microscopic life, and settles into a thin layer that might take centuries to form. Layer after layer, year after year, the seafloor becomes a record of everything that has ever touched the ocean. The deeper you look into those layers, the further you go back in time. It's not just a geological record, it's a living archive of the planet's history, preserved in silence and pressure. Scientists call this process sedimentation, but that word hardly captures what's happening. It's not just material falling, it's the world writing to itself, one particle at a time. When samples of this sediment are brought to the surface, they look like mud, grey, cold, and unremarkable. But under a microscope, that mud reveals intricate details, tiny shells of plankton, mineral fragments, pollen grains, chemical traces left by organisms that died long before humans appeared. Each layer corresponds to a moment in Earth's past. One might show evidence of an ancient volcanic eruption, its ash spread across oceans. Another might contain a sudden drop in carbon isotopes, marking a time when the planet cooled rapidly. Another could hold traces of meteorite dust, evidence of impacts that changed climates and ecosystems. The Emden Deep, like other trenches, collects everything. It doesn't discriminate between the ordinary and the catastrophic. Whatever falls eventually arrives here, joining the record. The ocean surface hides constant motion, storms, waves, currents. But beneath that motion lies an unbroken chain of memory. The deeper layers of sediment in the Emden Deep may be millions of years old. In them, scientists can trace the rhythm of glacial cycles, the rise and fall of sea levels, the chemistry of ancient atmospheres. Each isotope ratio, each microfossil adds to the story. It's a kind of natural data storage, written not in binary code but in the chemistry of the Earth itself. The challenge is reading it. Retrieving samples from 10 kilometers down is difficult enough. Keeping them intact is harder still. The pressure, the temperature, the delicate composition of gases all must be preserved to prevent contamination. When a core sample reaches the surface, it begins to change immediately. Gases expand, water evaporates, bacteria die. What scientists study in the lab is already a translation, a version of the deep that can survive in our world. Despite those difficulties, the cores retrieved from deep trenches have transformed our understanding of Earth's history. They show that the planet has never been stable for long. Oceans have grown and shrunk, temperatures have risen and fallen, life has flourished and vanished. The sediments of the Emden Deep, though less studied than those of the more famous Mariana, likely hold a similar record. They may contain the chemical fingerprints of ancient monsoon cycles in Asia, the ash of eruptions from the Indonesian archipelago, even the traces of early human activity carried by rivers into the sea. If one could read the layers like pages, the story would be continuous. A record of motion, climate, and life, extending back to a time when continents were in different places. Each new layer forms slowly, but the process never stops. Dust from deserts in China crosses the atmosphere and falls into the Pacific. Microscopic organisms die and sink. Bits of rock eroded from mountains wash into rivers and make their way to the ocean. Over thousands of years, those materials drift downward, joining the quiet accumulation on the trench floor. The Emden Deep is, in effect, the endpoint of countless journeys. Everything that begins on land eventually passes through the sea, and everything that enters the sea eventually finds its way to the bottom. It's a form of gravity that isn't just physical, it's temporal. Time itself seems to flow downward here, settling into layers that grow thicker as the centuries pass. Within those layers, there are clues not just to the past, but to the continuity of the planet's systems. Scientists can measure how much carbon is locked in the sediments and use that information to understand how the ocean regulates the climate. They can trace the movement of nutrients, the exchange of gases between water and atmosphere, the rise and fall of productivity in surface ecosystems. In that sense, the deep ocean is not just a passive archive, it's an active participant in maintaining balance. Every molecule of carbon buried in the sediment is one less in the air above. Without that process, the planet would have overheated long ago. The ocean keeps its own equilibrium, recording every fluctuation and correcting it in slow motion. Occasionally the record is disturbed. An earthquake or landslide can send avalanches of sediment cascading into the trench, mixing layers that were once separate. When that happens, time blurs. Old materials are lifted, new ones buried, and the sequence of events becomes harder to decipher. To a scientist reading a core sample, such disturbances appear as abrupt changes, sharp lines, broken patterns, layers of coarse debris among fine mud. Each one marks a moment of upheaval, a reminder that even the ocean's deepest places are not immune to change. The Emden Deep sits in a tectonically active region. Its walls are shaped by subduction, its floor by compression. Over centuries, the trench shifts, breathing in geological time. The sediment adapts, layering itself anew after every disturbance. The archive repairs itself, continuing the slow accumulation as if nothing happened. There's a paradox in studying something so slow and so permanent. The work itself is rushed by comparison. Expeditions have limited time. Ships are expensive to operate. Scientists lower their instruments, collect samples, record data, and move on, knowing they've only captured a fragment of a vast whole. Yet each fragment contributes to a larger picture. When the data from many trenches are combined, patterns emerge, planetary rhythms visible only across eons, ice ages, volcanic winters, warming periods, extinctions, all become part of a connected timeline. The deep ocean, in this way, becomes the memory of the Earth's metabolism. The Emden Deep's location makes its archive unique. It sits beneath waters that receive input from both the Pacific and the surrounding seas of Southeast Asia. The sediments here carry signals from monsoon systems, tropical rivers, and equatorial currents. They hold records of El Niño cycles, typhoons, and dust transport from the Asian continent. In a single core, you can trace connections between distant regions: volcanic ash from the Pacific Ring of Fire, organic matter from coastal ecosystems, mineral dust from deserts thousands of kilometers away. The trench gathers not only physical debris but the fingerprints of atmospheric and oceanic processes that link the planet together. There's another layer to this story, one that connects geology to biology. When organic matter sinks to the seafloor, it doesn't just settle and remain. Microbes living in the sediment continue to break it down, consuming the carbon and releasing gases like methane and carbon dioxide. Some of these gases are trapped in ice-like crystals called hydrates, stable only under high pressure and low temperature. These hydrates form reservoirs of energy, vast and largely untouched, though their stability depends on the same conditions that make the deep ocean what it is. A warming world could destabilize them, releasing stored methane back into the atmosphere. The sediments of the Emden Deep, in that sense, are not just a record but a potential key to understanding the future. What has been buried can always return. To those who study them, sediment cores are like time machines. A sample only a few meters long might represent tens of thousands of years. Deeper cores reach millions. By examining variations in grain size, color, and chemical composition, scientists can reconstruct entire eras. The work requires patience and precision. A single mislabeled layer can throw off interpretations by centuries. Yet despite the difficulty, the process continues, expedition after expedition, each one retrieving a few more pieces of the planet's past. Together they form a narrative of resilience and change, a narrative that no human witness could ever have seen firsthand, but that the Earth remembers perfectly. What makes the Emden Deep particularly fascinating is its remoteness from direct human influence. Unlike coastal areas or continental shelves, it receives little disturbance from modern activity except what drifts down through the water column. Its sediments, therefore, are cleaner records of natural variation. They show how the planet behaved before industry, before cities, before noise. In those layers, scientists can see what Earth was like when it was still governed solely by its own cycles. That baseline is essential for understanding how much we've altered the system since. By comparing old layers with new ones, researchers can measure the impact of human civilization on ocean chemistry. Traces of plastics and pollutants now appear where none existed before. Even isotopes from nuclear testing can be found in the upper centimeters of sediment, marking a new geological epoch, the Anthropocene, recorded forever in mud. To imagine the deep as an archive is to rethink the meaning of time. In the human world, time is linear, marked by events and progress. In the deep, it's cumulative, Nothing is lost, everything becomes part of something else. The past doesn't vanish, it compacts, solidifies, and endures under layers of newer material. That accumulation creates stability. It's what allows the ocean to buffer the planet's climate, absorb carbon, and sustain life. The archive is not static. It's dynamic equilibrium, change written as continuity. Sometimes, during deep-sea dives, explorers describe seeing faint clouds drifting above the seafloor. These are not living creatures, but fine particles suspended in water, disturbed by movement. Each one is a fragment of history, a piece of dust that might have fallen from the sky centuries ago. When lights from the submersible catch them, they shimmer briefly, reflecting the beam before disappearing again. In that moment, the divide between past and present seems to dissolve. The same particles that record history are still in motion, still part of a living system. The archive breathes, however slowly. The idea of reading Earth's history through mud might seem unromantic, but it's one of the most powerful tools we have for understanding our place in time. The deep doesn't just store facts, it stores context. It shows that every change we make at the surface will, sooner or later, become part of the planet's record. The plastic fibres, the industrial ash, the chemicals, they all descend eventually. In 1,000 years, there'll be just another layer in the archive, a thin stripe in a column of sediment marking the brief period when one species reshaped the world. The deep doesn't judge, it just records. When the submersible lights switch off, the archive returns to darkness. Sediment continues to fall. Microbes continue their quiet work. Pressure keeps everything in place. The process is so slow that it feels eternal, but it isn't. Nothing is. Over millions of years, even these trenches will change. The plates will shift, the ocean floor will move, and today's deepest points will someday rise again as mountains. What was once archive will become landscape. The record will continue in a new form, because that's how Earth functions. Nothing stays buried forever. If you were to reach down and touch the seafloor of the Emden Deep, which no human hand ever will, you would be touching time itself. Each particle beneath your fingers would represent a moment, some from yesterday, some from 100,000 years ago. And beneath those, older still, layers that remember a world without humans, without mammals, without even land plants. The weight of that continuity would be impossible to feel in any physical sense, but it would be there all the same. The ocean's archive is the closest thing Earth has to memory without consciousness. It remembers because it cannot forget. The Emden Deep is not just a geographical point. It's a library without shelves, without light, written in chemistry and motion. Every descent into it is a visit to the past, every core a translation of silence into understanding. And above it all, the ocean moves, oblivious to being studied, continuing the slow work of recording the planet's life one grain at a time. The deeper humans try to go, the more the ocean turns into an equation. Every metre of descent demands an answer to pressure, to temperature, to endurance. Nothing in this environment forgives error. To reach the Emden Deep requires not only courage but precision measured in millimetres. The technology that makes such journeys possible is a balance between simplicity and strength, a constant negotiation between what can survive and what can function. In many ways, the machines that explore the deep are less like vehicles and more like instruments. Tools built to translate an environment too extreme for the human body into information that can be understood at the surface. The earliest attempts to reach great depths were experiments in defiance. Before anyone knew exactly how much pressure the ocean could generate, people built spheres of steel and glass and lowered them on cables, trusting in mathematics and hope. The bathysphere dives of the 1930s proved that human descent was possible, but also that it was terrifyingly fragile. A crack, a leak, even a small defect could mean immediate collapse. Those early explorers, William Beebe and Otis Barton, descended less than a kilometre off Bermuda and described what they saw through tiny windows, jellyfish glowing in the dark, shapes moving in patterns never seen before. It was the first time anyone had truly looked into the abyss. Everything since has been an extension of that idea, made safer by engineering and science, but driven by the same curiosity. Over the decades, technology evolved from spherical cages to autonomous submersibles. The basic challenge remained unchanged. Build something that can resist a pressure greater than any mountain could bear. The deeper the dive, the thicker the walls must be, and the smaller the space inside becomes. Engineers learned that strength alone wasn't enough. Materials had to be resilient, capable of deforming slightly without breaking. Titanium replaced steel. Syntactic foam, plastic infused with glass microspheres, became the standard for buoyancy. Electronics were sealed in oil to equalize pressure. Every component had to work flawlessly because a single failure could compromise the entire mission. When designing a craft to reach a place like the Emden Deep, engineers start by calculating pressure, more than 1,000 atmospheres. That number defines everything: the thickness of the hull, the shape of the sphere, the type of window glass, even the way cables are connected. Spheres are chosen because they distribute stress evenly, minimizing weak points. Flat surfaces like those on airplanes or ships would collapse instantly. Inside the sphere, space is limited. There's room for 2 people at most, seated close together, surrounded by controls, sensors, and life support systems. It's not a cockpit in the familiar sense. It's a capsule of safety surrounded by crushing danger. The descent takes hours, and the silence grows heavier with depth. The only sound is the slow hum of pumps and the occasional creak of metal adjusting under pressure. The submersible DSV limiting factor, which successfully reached the Emden Deep, represents the culmination of nearly a century of engineering progress. Its pressure hull is a sphere of forged titanium over 90 millimeters thick. It was designed to reach any depth on Earth repeatedly, not as a one-time experiment, but as a reusable research tool. The engineers who built it had to solve problems that sound simple, but aren't. How do you transmit data through 10 kilometers of water? How do you manage buoyancy when every material compresses differently under pressure? How do you ensure that systems meant to keep humans alive won't fail silently in an environment where no help can come? The answers required years of testing, failure, and refinement. Communication between the submersible and the surface is limited by the physics of water. Radio waves don't travel well through it, so the link must rely on sound. Messages are sent as coded acoustic pings, each one carrying small amounts of data. Yet at the surface, computers translate those sounds into text or readings. The process is slow, like trying to talk through walls using Morse code. Real-time video is impossible. Signals degrade and scatter long before they reach the surface. That means explorers at the bottom operate largely on their own. They record everything, but what they see won't reach the ship until they return. Each dive becomes a kind of delayed conversation with the world above. Navigation in the deep is equally limited. GPS signals stop at the surface. Once submerged, the submersible relies on inertial guidance and sonar. Acoustic beacons dropped from the ship create a virtual map, but even that is imprecise. A few meters of error can mean missing a target entirely. Pilots learn to move slowly, using the sonar's grainy images as their guide. The darkness makes orientation difficult. Up and down become relative. When the lights are off, there is no horizon, no reference at all. Every maneuver must be deliberate, every movement calculated. One wrong adjustment could stir up a cloud of sediment that blinds the cameras for hours. The instruments aboard these machines are as remarkable as their structure. Cameras capable of withstanding pressure, record in high definition. Robotic arms collect samples with delicacy that seems impossible for mechanical devices. Sensors measure temperature, salinity, and chemical composition of the water. Each component is encased in protective housing, pressure tested to survive conditions far beyond the human limit. Even so, every dive carries risk. Seals degrade, electronics short-circuit, batteries lose efficiency in the cold. The ocean's pressure finds weaknesses humans can't see. Every success is a temporary victory against an environment designed to resist intrusion. Supporting these descents are surface ships that act as control centres. They deploy the submersible, monitor its status and coordinate recovery. The process begins long before the dive itself. Engineers check every system repeatedly. Pilots rehearse procedures, from ballast control to emergency ascent. The craft is lowered into the water by crane, and once it detaches from its support cables, it begins its slow fall. Descent speed is typically around 1.5 meters per second, fast enough to progress but slow enough to monitor systems. It takes roughly 4 hours to reach the floor of the Emden Deep. During that time, the crew watches readings change gradually. Light fades to zero, pressure climbs steadily, and temperature drops to near freezing. Inside the capsule, the atmosphere is controlled but minimal. Oxygen is supplied from tanks, carbon dioxide is scrubbed by chemical filters, humidity is regulated by desiccant packs. There's no space for comfort. Movement is restricted. Communication is limited to short exchanges. The pilots work through checklists, adjusting ballast and trim, keeping the craft level. The darkness outside is complete until the external lights are turned on, revealing a world of fine silt and drifting particles. At that moment, the distance between human civilization and the ancient stillness of the deep feels infinite. One of the greatest challenges in deep exploration is energy. Batteries must be powerful enough to run lights, motors, and instruments for hours, yet compact and reliable under pressure. Modern submersibles use lithium-ion systems similar to those in electric cars but modified for stability. Power management becomes a form of life support. Conserve too little, and instruments fail. Conserve too much, and navigation becomes impossible. Engineers design redundancies into every circuit, knowing that a single short can mean loss of control. The margin for error is non-existent. The ocean does not forgive oversight. When unmanned vehicles are used, the technology shifts focus from survival to endurance. Remotely operated vehicles, or ROVs, are connected to the surface by cables that carry power and data. Autonomous vehicles, or AUVs, operate freely, following programmed routes and returning with data later. Each has advantages. ROVs provide real-time control but are limited by tether length and risk of entanglement. AUVs can travel farther and map larger areas but must navigate without communication. The deep requires both kinds, machines that can endure isolation and machines that can remain tethered to the world above. Together they form the eyes and hands of science where the body cannot go. Mapping the Emden Deep with these technologies is like trying to photograph a mountain range at night using a flashlight. The area is vast and visibility limited. Sonar mapping provides outlines, showing ridges and slopes, but details remain elusive. Even high-resolution sonar has limits. Sound waves bend, scatter, and lose energy. To build a complete picture requires multiple passes from different angles, each one stitched together by software to form a model. It can take months to map a few square kilometers, yet those maps are essential. They reveal patterns in the terrain, fault lines, landslide zones, sediment flows, that help scientists understand how the trench evolves over time. The instruments designed for sampling are no less complex. Corers penetrate the sediment to collect columns of material several meters long. Traps capture drifting particles of marine snow as they fall. Water samplers seal at specific depths, preserving the chemical composition of the surrounding environment. Even the simple act of retrieving these samples requires ingenuity. The pressure difference between the seafloor and the surface can cause containers to rupture or leak. Engineers design valves that close automatically at depth, sealing the contents before ascent. Every sample retrieved intact is a small triumph over physics. The success of these technologies depends not only on design but on the collaboration between disciplines. Engineers, biologists, chemists and pilots work together, each relying on the others. The pilot trusts the engineer who built the hull. The biologist trusts the pilot who maneuvers the arm. The entire team trusts the ocean to allow them time. The relationship between human and machine becomes intimate, almost personal. After each dive, the submersible is inspected like a living being, its joints examined, its seals cleaned, its systems recalibrated. Every scratch tells a story of pressure endured. The machines become part of the crew, extensions of human persistence. The cost of this technology is immense. A single dive can require millions of dollars in preparation and equipment, but the payoff is measured not in money, but in knowledge. The first clear images from the bottom of the Emden Deep, the first samples, the first readings, all represent steps toward understanding a part of Earth that has remained untouched for billions of years. Each successful dive pushes the boundary of what is possible. Each failure teaches something new about how the planet resists us. In that struggle between curiosity and resistance lies the essence of exploration. The evolution of deep-sea technology mirrors the evolution of human understanding. The more we learn, the more complex our questions become. The machines we build are reflections of those questions, stronger, smarter, more capable of surviving where we cannot. Yet even the most advanced submersible remains a visitor. It enters the deep briefly, gathers what it can and leaves. The ocean remains indifferent. Its systems continue, its silence unchanged. Technology allows us to witness, not to conquer. There's a kind of humility built into the design of these machines. Every bolt, every seal, every line of code acknowledges limitation. Engineers know they cannot build perfection. They can only build resilience, systems that can tolerate failure without catastrophe. That philosophy mirrors the deep itself, where life endures not through strength, but through adaptation. The machines that reach the Emden Deep are, in a way, expressions of that same principle. They survive by yielding slightly, by bending instead of breaking, by embracing the inevitability of pressure rather than resisting it completely. The deeper exploration goes, the more it depends on automation. Future missions will likely involve fleets of small autonomous vehicles working together, sharing data through acoustic networks. These machines will map the trench in detail, sampling without supervision, learning to navigate on their own. Artificial intelligence will analyze the data in real time, identifying features and anomalies faster than any human team could. The technology is moving toward independence, the ability for exploration to continue even without us physically present. Yet even as machines become more capable, their purpose remains human. They exist to satisfy curiosity, to translate the silent depths into knowledge we can understand. When a submersible ascends after hours at the bottom, the engineers on the surface wait, scanning the horizon for the first sign of the capsule breaking through the waves. The recovery process is delicate. The crane lowers cables, the craft is secured, and slowly it is lifted back aboard. The hull is inspected, the samples removed, the data downloaded. There's always a moment of quiet before anyone speaks. The relief is immediate but understated. The technology has done its job. The ocean has returned what it borrowed, and for a brief moment, humans have touched the unreachable. Later, in laboratories and offices far from the sea, the data is analysed, the footage reviewed, the samples studied. The images of silt, rocks, and small drifting creatures become part of a larger understanding. The technology fades into background again, replaced by the science it enabled, but the memory of descent remains, of pressure, silence, and the fragile barrier between existence and oblivion. The next dive will begin the same way, with calculations, checks, and the slow fall into darkness. And with each descent, the machines will carry us a little farther, their lights reaching a little deeper, until the Emden Deep reveals another fraction of its truth. Every descent into the deep begins with a human decision. Someone has to look at a map and decide that a certain place, invisible and unreachable, deserves to be seen. The machines may do the work, the sensors may collect the data, but it is people who give the deep its meaning. The Emden Deep exists whether or not anyone studies it, but its story only becomes part of ours when a person chooses to go there. The human connection to the abyss is not about conquest or discovery in the traditional sense. It's about understanding what drives us to keep searching for places that do not need us, and what those places reveal about ourselves once we find them. Standing on the deck of a research ship before a dive, the contrast between the world of the surface and the world below could not be sharper. The air is full of noise, wind, waves, engines, voices. Instruments hum, cables move, lights flash. There's motion everywhere, a kind of restless preparation, and yet beneath that surface there is complete stillness. The deep ocean does not care about schedules or plans. It waits, silent and unchanged, as humans prepare to enter it for a few hours. For those who make that journey, the shift from chaos to calm can be overwhelming. Inside the submersible, surrounded by thick metal walls, sound fades away. There's no horizon, no sense of distance. The mind becomes aware of itself in a way that rarely happens on land. Pilots often describe the moment of descent as a form of detachment. As the submersible begins to sink, the noise from the surface recedes, replaced by the rhythmic pulses of ballast adjustments and the faint vibrations of machinery. The descent takes hours, and during that time, the outside world disappears. There is nothing to see for long stretches, only darkness, occasionally broken by small flashes of bioluminescence. Those flashes are the closest thing to stars the ocean has, and in the confined space of the submersible, they seem to drift past slowly, silent and indifferent. For some it's meditative, for others unnerving. There is nowhere to go but down, and nothing to do but wait. When the bottom finally appears, illuminated by artificial light, it's rarely dramatic. There are no grand formations or bursts of colour, only sediment and small movements, and yet that simplicity holds a strange power. The realization that you are sitting at the lowest point of one of Earth's deepest places, surrounded by an environment untouched by human life, changes how you think about the world above. The Emden Deep is not a spectacle, it's a mirror. It reflects back the scale of what we don't know and the limits of what we can reach. In that sense, every descent is as much an inward journey as an outward one. The people who choose to explore the deep often speak of curiosity as their motive, but beneath that is something deeper, an instinct to connect. Humans have always sought connection, whether through exploration, art or science. The ocean represents the final barrier, a part of the planet that resists familiarity. To reach it is to bridge a gap not just of distance, but of comprehension. When explorers like Victor Vescovo or Don Walsh speak about their dives, they rarely focus on the technical achievements. Instead, they describe the feeling of isolation, the awareness of fragility, the way time slows until every sound becomes significant. In the dark, surrounded by pressure that could destroy a submersible in an instant, the boundary between human and machine fades. What remains is consciousness, alone in a space that has never known it before. That isolation is not without consequence. The experience of being cut off from all communication from light and sound changes perception. Inside the sphere, senses become heightened. The hum of an instrument, the flicker of a display, the soft hiss of oxygen flow, each becomes a reminder that life continues in an environment where it should not. For some, that awareness brings calm. For others, it brings fear. Both reactions are valid, because they come from the same source, an understanding of vulnerability. The ocean does not threaten, it simply exists. But in its existence, it exposes the fragility of everything human. That fragility, paradoxically, is what makes connection possible. It reminds us that we are participants in the same system we seek to understand. The relationship between humanity and the deep sea has always been defined by paradox. We depend on the ocean for life. Its currents regulate climate, Its ecosystems sustain food chains, its chemistry stabilizes the air we breathe, and yet we know so little about it. The deeper we look, the more we realize how incomplete our knowledge is. That gap between dependence and ignorance creates a kind of tension. Exploring the deep becomes both a scientific necessity and an existential question. Why do we seek to understand what we can never fully reach? The answer might be simple, because to understand the deep is to understand the planet itself, and by extension, ourselves. When scientists talk about exploration, they often use the language of discovery, depths reached, species found, data collected. But behind those facts are people making choices in real time. A pilot deciding whether to descend a few meters farther, a technician adjusting a pressure gauge, a scientist watching a monitor for hours, waiting for a signal to return. These actions are not heroic in the traditional sense, but they represent a kind of patience that defines human progress. The Emden Deep, like space, rewards endurance more than ambition. Success depends on remaining calm in conditions that defy instinct. It's a quiet kind of courage, the kind that measures achievement not by distance travelled, but by persistence in the face of the unknown. The emotional connection to exploration often appears after the fact. Once the data is collected and the submersible is back on the surface, there's a moment when the enormity of what was just experienced sinks in. Pilots speak of looking at the horizon differently afterward. The sea that once seemed familiar becomes mysterious again. They describe a sense of perspective that lingers, an awareness that the world beneath the surface is not separate but continuous with the one above. It changes how they think about environmental responsibility, about the fragility of ecosystems, about the value of patience in a world that measures success by speed. That same sense of connection extends to those who never dive at all. The images and data collected from the Emden Deep reach classrooms, documentaries, and research papers. They shape how millions of people imagine the ocean. A photograph of a translucent amphipod drifting across the seafloor, or a video of fine sediment moving in slow clouds, becomes a window into a world that most will never see. The act of sharing that image is itself an extension of human connection. Technology bridges distance, but emotion bridges meaning. A viewer sitting at home, watching footage from 10 kilometers below the surface, participates in the same curiosity that drove the descent. That shared curiosity, multiplied across generations, is what keeps exploration alive. In many ways, the connection to the deep mirrors the connection to space. Both are environments beyond normal experience. Both require complete dependence on machines. Both confront us with silence. Astronauts and aquanauts often describe similar feelings of awe and insignificance. The difference is direction. One looks up, the other down. But the psychological effect is the same. When removed from the familiar, surrounded by vastness, the human mind resets its scale. Problems that once felt large shrink. Time feels different. In the deep, every minute stretches. In space, every view expands. Both remind us that our sense of control is temporary. This awareness influences how we see progress itself. Technology may make descent possible, but it's empathy that makes it meaningful. The scientists who study the organisms of the Emden Deep do so not out of profit, but out of reverence for life in its most resilient form. They see in those microorganisms a reflection of endurance, of persistence without recognition. It's the same quality that defines exploration, continuing to seek understanding even when no one is watching. The connection between human curiosity and deep-sea life is not metaphorical, it's literal. Both exist in environments that demand adaptation and reward patience. For the people involved in these missions, the experience often leaves traces that go beyond science. Some describe feeling an emotional weight that takes time to process. The deep does not provide spectacle or comfort. It provides perspective, and perspective can be unsettling. After returning to the surface, the noise of ordinary life can feel excessive. Lights seem too bright, conversations too fast. It takes days or weeks to adjust. But with that adjustment comes something lasting, a quiet awareness of scale, the knowledge that beneath every ship, every coastline, there is a world operating in silence, holding the history of the planet, indifferent to our noise but essential to our existence. The Emden Deep, like other trenches, has become a meeting point between human effort and natural permanence. Every expedition connects the transient with the eternal. The people who go there leave nothing behind except data, yet they take with them a sense of belonging that comes only from having touched something absolute. The deep doesn't need witnesses, but it changes those who become them. That transformation is subtle but profound. It alters how people think about exploration, about risk, about the meaning of discovery. The ocean becomes not a barrier but a bridge, an environment that links life across time, from the first microbial forms to modern humanity. It's easy to romanticize exploration, but those who experience it know it's mostly work. Hours of preparation, technical challenges, physical discomfort. The glamour fades quickly. What remains is purpose. And in that purpose, the connection deepens. Pilots speak of developing trust in their machines as if they were companions. Scientists speak of respect for the deep as if it were a living being. That anthropomorphism isn't sentimentality, it's recognition. When you spend enough time studying or surviving in a place that could destroy you effortlessly, respect is the only rational response. The human connection to the deep is built on that respect, on understanding that survival there depends not on dominance, but on cooperation between mind, machine, and environment. There's another kind of connection that often goes unnoticed, the collective one. Every deep-sea expedition involves dozens, sometimes hundreds, of people working together across continents. Engineers in one country design components that are tested in another, assembled on a ship crewed by multiple nationalities, launched into international waters. The Emden Deep, lying between nations, becomes a neutral space where collaboration thrives. In a world often divided by borders, the ocean offers a kind of unity. The pursuit of knowledge doesn't recognize political boundaries. It follows the shape of curiosity, and that shape is global. For the people who have stood on the deck after a successful dive, there's a ritual silence that follows recovery. It's not the silence of exhaustion, but of understanding. The ocean has given something: data, perspective, a glimpse into the unknown. And the crew absorbs the weight of it. They might laugh or cheer later, but in that moment there's usually quiet. The human connection to the deep is not loud. It's not about celebration. It's about acknowledgement. A recognition that for all our technology and intellect, we remain guests in a world far older and more enduring than ourselves. That recognition extends beyond science. Artists, writers, and thinkers have long drawn inspiration from the sea's depth. The unknown beneath the surface has become a metaphor for introspection, for the parts of ourselves we can't easily see. But for those who have actually gone there, the metaphor feels unnecessary. The experience is literal enough. The deep doesn't represent mystery, it is mystery. To witness it directly is to realize that mystery is not something to be solved, but something to be experienced. The connection it offers is not to knowledge but to humility. The Emden Deep, with its pressure, its silence, and its age, teaches a kind of patience that modern life rarely allows. The ocean moves at a pace that makes human urgency seem trivial. Sediment settles over centuries. Life adapts over millennia. To study it is to slow down, to align thought with geological time. That shift in perspective is perhaps the most profound human connection of all. The understanding that meaning doesn't always require speed or visibility. It can exist quietly, far beneath the surface, sustained by continuity rather than change. Every descent into the deep is a reminder that connection requires distance. To appreciate the planet, we sometimes have to leave its familiar parts behind. The people who descend into the Emden Deep are not escaping the world but returning to it in a different form. They go to the place where light ends where sound disappears, where the boundary between life and environment dissolves, and they come back carrying something invisible but essential: awareness. That awareness filters through research, through education, through art, until it becomes part of how we collectively see the world. The human connection to the deep is, in the end, a connection to ourselves, to the parts of our nature that seek stillness in the midst of noise and meaning in the face of silence. And so the descent continues, each journey adding to the long conversation between humanity and the ocean. The Emden Deep remains patient, indifferent yet accommodating, allowing us to visit and to learn. Every dive reaffirms the same truth: that connection does not require understanding, only presence. The lights fade, the engines stop, and in the quiet between movements, the bond between the surface and the deep holds steady, as constant as pressure and as enduring as time itself. The ocean has always been both a mirror and a warning. It reflects everything that happens above it, absorbing what the world produces and returning it in altered form. For centuries, it has taken what we give it: heat, carbon, debris, sound, and stored it quietly, as though endless capacity were part of its nature. But capacity is not infinity. The future of places like the Emden Deep depends on how long that illusion of limitlessness can endure. The deep has survived ice ages, meteor impacts, and the slow rearrangement of continents. But it now faces a kind of change that is faster and more deliberate than anything in its history. The future beneath us is being shaped, grain, by choices made on the surface. When scientists first began to study the chemistry of the deep ocean, they discovered something unsettling. The sediments, those ancient layers that record millions of years of history, were beginning to change in ways that didn't match natural cycles. Levels of carbon and nitrogen shifted abruptly in the most recent strata. Tiny fragments of plastic appeared where none should exist. Isotopes from nuclear testing were detectable in cores collected from 10 kilometers below the surface. It was clear that human activity had reached the very bottom of the planet. The Emden Deep, one of the most remote and inaccessible places on Earth, was no longer untouched. Even there, in the dark and silence, the traces of our existence were settling. These changes raise difficult questions about what it means to explore and what it means to disturb. The same technologies that allow us to reach the deep also allow us to exploit it. Advances in robotics and materials science have made deep-sea mining a possibility, and for some, an inevitability. Vast fields of metallic nodules, rich in cobalt, nickel, and rare earth elements, lie scattered across abyssal plains around the world. The demand for those metals, driven by renewable energy and electronics, has turned the seafloor into an economic frontier. Companies and governments have begun to plan for extraction, arguing that it will be less destructive than mining on land. But the deep is not a wasteland. It is an ecosystem, fragile and interconnected, and once disturbed, it cannot be restored on any human timescale. The Philippine Trench, where the Emden Deep lies, contains geological formations that may attract such interest in the future. Mineral deposits, methane hydrates, and other potential resources exist in abundance at great depth. So far, exploration there has been scientific, not industrial, but the line between the two is thin. The same mapping technologies used to study biology and geology can also identify exploitable materials. The temptation to turn exploration into extraction is strong. The argument always begins with necessity, energy, progress, development, and ends with promises of minimal impact. Yet every disturbance, even small, changes the chemistry and structure of the deep. Sediment clouds stirred by machinery could take centuries to resettle. Noise from mining equipment could disrupt the communication of deep-sea organisms that rely on vibration to sense their environment. The future of the deep, if guided by convenience, could easily become a record of irreversible mistakes. For now, The Emden Deep remains largely beyond industrial reach, protected by its depth and difficulty. But protection by inaccessibility is temporary. Technology evolves faster than ecosystems. Machines that can survive the pressure of 10,000 meters already exist. The cost of deep exploration is decreasing. With each new generation of autonomous vehicles, the barrier between curiosity and exploitation grows thinner. The challenge facing science is to stay ahead of that curve, to understand the deep well enough to protect it before it becomes another frontier of extraction. Knowledge must come before ownership, and empathy before profit. There's also the broader question of climate. The deep ocean is not insulated from the atmosphere. It's connected to it through slow, continuous circulation. Water from the surface sinks at high latitudes, carrying dissolved gases that take centuries to reach the depths. What we emit now, carbon dioxide, heat, pollutants, will eventually descend, altering the chemistry of the Hadal zones. Already, measurements show changes in pH, a sign of acidification creeping downward. The consequences of that process are still uncertain, but the trend is clear. Even in the Emden Deep, where life is adapted to extremes, shifts in acidity and temperature could reshape the microbial balance that underpins the ecosystem. The smallest organisms may survive, but their composition will change, and with them, the chemistry of the seafloor itself. The deep archive of the planet is being rewritten even as it continues to record. Scientists who study these processes speak with both urgency and restraint. They know that the deep responds slowly. A change that takes decades to notice may take centuries to reverse. That delay can create complacency. The ocean absorbs impact silently, giving the illusion that everything remains stable. By the time effects become visible, they're often irreversible. In that sense, the future of the Emden Deep is not separate from the future of the surface. The two are part of the same system, separated by distance but united by cause and consequence. The water that falls as rain, flows through rivers and enters the sea will eventually join the currents that feed the trench. Every act of pollution, every release of carbon, every change in temperature will find its way downward. Nothing stays on the surface forever. In recent years, international organizations have begun to discuss the need for legal frameworks to protect the deep ocean. Treaties, conventions, and environmental regulations have been proposed, but enforcement is difficult. The vastness of the sea makes monitoring nearly impossible. Satellite technology can track surface activity, but not what happens 10 kilometers below. The Emden Deep lies in international waters, a region beyond national jurisdiction. Its future depends on collective responsibility, on the willingness of nations to treat the deep as a shared heritage rather than an exploitable resource. That kind of cooperation requires perspective, and perspective is what exploration provides. The more we understand about the deep, the harder it becomes to view it as empty. The irony is that the same curiosity that drives exploration could also protect it. When people see images from the deep, when they learn about its ecosystems and geology, they begin to value it not as a concept, but as a reality. The emotional connection created by knowledge is a form of preservation. Public awareness can influence policy faster than data alone. The challenge, then, is communication. Translating the language of science into a story that resonates with people who will never see the deep firsthand. Every expedition, every documentary, every article contributes to that story. The Emden Deep, once an obscure point on a map, is becoming a symbol of what remains unknown and therefore worth protecting. But the future of exploration itself is also changing. The next generation of researchers may never physically enter the deep. Robotic systems, remote laboratories, and artificial intelligence will take over much of the work. Machines will descend where humans no longer need to go, sending back continuous streams of data. The experience will become less personal, but more persistent. Instead of rare expeditions, there will be constant observation. Networks of autonomous vehicles could patrol the trenches, measuring temperature, pressure, and chemistry year-round. That kind of surveillance will provide unprecedented insight into how the deep functions, but it may also change how we relate to it. When the mystery becomes routine, the emotional connection may fade. Protecting the deep will then depend not on wonder but on responsibility. The ethical questions surrounding this future are complex. How much interference is acceptable in the pursuit of knowledge? Should we disturb ecosystems to understand them, or should we let them remain unknown? The answer, as always, lies in balance. Exploration can coexist with preservation if guided by restraint. The deep does not demand reverence, only respect. That respect comes from understanding limits, technological, ethical, and ecological. The Emden Deep reminds us that there are still boundaries worth keeping, not because they are unreachable, but because they define what kind of species we choose to be. There is another aspect of the future that's less visible but equally important: the role of imagination. The deep has always influenced how we think about mystery, fear, and the unknown. As we learn more about it, that influence will evolve. Children growing up seeing real footage of the deep may no longer imagine it as empty darkness, but as a living, complex world. That shift in imagination changes how societies value the environment. Curiosity becomes empathy. The future of the deep is therefore tied not only to science but to culture, to how we tell its story and how we see ourselves within it. In laboratories around the world, samples collected from the Emden Deep are still being analysed. Some contain microbial strains that could lead to new medicines or industrial applications. Enzymes adapted to high pressure and low temperature have potential uses in biotechnology. The irony is that preservation and progress are sometimes aligned. The more unique the deep's biology is, the more valuable it becomes, not as a resource to extract, but as a source of understanding. Protecting it protects opportunity. In that sense, conservation and innovation are not opposites but partners. The deep's future could depend on framing it as something to study sustainably, rather than to exploit destructively. When people talk about the future of the ocean, they often focus on the visible, the coral reefs, the fisheries, the rising tides. The deep remains abstract, distant, too far removed from daily life to seem urgent. Yet it is the foundation that supports everything else. The circulation of heat and carbon, the stability of ecosystems, even the composition of the atmosphere depend on what happens below. The Emden Deep is one of the places where those processes converge, where the balance of the planet is maintained silently. To imagine a future where the deep remains stable is to imagine a future where Earth itself remains habitable. The changes we make now will determine how that future unfolds. If exploration continues with awareness, the deep could become a symbol of coexistence between humanity and nature, proof that curiosity and respect can share the same space. If exploitation prevails, the deep could become a monument to short-sightedness, another ecosystem sacrificed for temporary gain. The choice lies not in technology, but in perspective. We already have the tools to reach the bottom. What we lack is the patience to treat what we find there with care. There are reasons for optimism: the increasing collaboration between nations, the involvement of non-governmental organisations, the growing public interest in ocean conservation, all point to a shift in awareness. The more people understand the deep's importance, the more likely it is to be protected. The Emden Deep, once a scientific curiosity, is slowly becoming a symbol of something larger: the need to balance exploration with preservation, progress with restraint. Its future depends not on isolation but on inclusion, on being part of the global conversation about the planet's well-being. At the same time, the deep remains a reminder of humility. For all our technology, we can still only observe it indirectly. We can measure, sample, and record, but we cannot live there. It resists permanence, allowing only visitation. That limitation may be what saves it. The deep does not yield easily, and that difficulty forces reflection. It ensures that only those willing to invest time, resources, and care can reach it. Perhaps that exclusivity, unintentional though it is acts as a kind of natural safeguard, a reminder that not everything is meant to be convenient. The future beneath us will unfold slowly. The ocean moves in centuries, not years. The consequences of today's actions will be measured long after those who caused them are gone. But in that slow motion lies hope. The same patience that defines the deep also allows recovery. If given time, ecosystems can heal, sediment can settle, balance can return. The deep teaches endurance. Perhaps it can teach redemption as well. When explorers descend into the Emden Deep in the decades to come, they may not find it untouched, but they will still find it live. The sediment will still fall, microbes will still metabolize in darkness, the ocean will still record the planet's story. The question is what that story will say about us, whether it will describe a species that learned to coexist with its world, or one that mistook endurance for emptiness. The deep will not answer, it will only remember. And long after the noise above fades, that memory will remain, layer upon layer, holding the truth of how we treated the world beneath us. The return begins long before the ascent. It starts with a change in the tone of the submersible's instruments, the quiet mechanical signal that the mission is ending. For hours the machine has rested at the bottom, motionless except for the faint adjustments needed to stay level. The lights have moved across the seafloor, capturing details that no human eye had seen before. Now, as ballast weights release and the ascent begins, there's no sense of motion, only a slow transition. The pressure outside remains enormous, but it lessens gradually. The depth gauge shows the numbers rising 1 meter at a time. Inside the capsule, the air stays still. The only sounds are the clicks of valves and the soft murmur of water flowing past the hull. The journey upward feels longer than the descent. On the way down, anticipation fills every second. On the way up, patience becomes the only rhythm. The darkness remains absolute for a long time, broken only by the faint glow of bioluminescent organisms drifting past the window. Each flash is momentary, a single pulse of blue or green light fading into black again. They appear at random, some near, some far, like silent signals marking the invisible road home. The pilot watches without speaking. After hours in the deep, even small movements feel like conversation. The ocean communicates in intervals of light, and the human mind adjusts to its pace. Gradually pressure decreases. The hull expands by fractions of a millimeter, the sound of metal adjusting echoing faintly through the interior. The instruments show normal readings, but habit keeps everyone alert. The deep does not forgive complacency. A small malfunction here can still end everything. The ascent is automatic but constantly monitored. The pilot checks the thrusters, the oxygen levels, the scrubbers. Each gauge becomes a heartbeat. In the confined space, focus replaces fatigue. The crew says little, not because of fear, but because silence feels appropriate. There's an unspoken respect for the weight they've left behind, for the world that will close over their absence without a trace. As the submersible rises through the lower Hadal zone, the temperature begins to climb slightly. It's a difference of degrees, but it feels like the approach of something familiar. The darkness is still complete, but the pressure has dropped enough that the water density changes, affecting the way light behaves. The external cameras record subtle variations, shadows where before there was only uniform black. The ascent crosses invisible boundaries between layers of the ocean, each one a transition in temperature, salinity, and life. The Hadal becomes the abyssal becomes the bathyal. These distinctions mean little to the ocean itself, but to the people inside the submersible, they're milestones. Each one marks progress toward air, noise, and motion. In the middle depths, currents begin to stir. Unlike the stillness of the trench floor, these layers are restless. Water moves in slow sheets, sometimes pushing the submersible sideways, sometimes holding it in place. The pilots adjust ballast to maintain balance, correcting drift with short bursts from the thrusters. The darkness thins here, not with visible light, but with life. The number of bioluminescent organisms increases, the blackness becomes less absolute. Around the capsule, clouds of plankton flicker in response to the disturbance. To the cameras, it looks like snowfall in reverse, tiny lights rising instead of falling. The crew watches without speaking. After so many hours in silence, the motion feels alive. At about 2,000 meters, sound begins to return. It starts faintly, like a distant vibration, then slowly becomes identifiable as the noise of the surface transmitted through layers of water. The low hum of waves, the muted roar of wind filtered by kilometers of density. The ocean is not silent here. It carries the echo of the world above, softened but recognizable. For the first time since the descent, there's a sense of connection to something beyond the submersible. The crew can speak freely now, their voices no longer muffled by the feeling of isolation that defined the deep. The conversation is minimal, practical, but the tone is different. Relief has a sound even when unspoken. As they continue upward, the light begins to shift. It doesn't appear suddenly. It arrives as a gradient. The deep black turns into a faint blue, almost imperceptible at first. The eyes take time to adjust. What looks like imagination at one moment becomes real the next. The cameras register the change before the mind does. Then, finally, there's a subtle brightness outside the window, enough to outline the drifting particles in the water. The ocean no longer feels infinite. There is direction again, orientation, a faint sense of where the surface might be. That recognition carries a kind of weight. It marks the return not only to light, but to gravity of another kind, the return to being part of the visible world. Approaching 1,000 meters, the ocean begins to change personality. The water is warmer, the density lower, the movement more chaotic. The submersible rocks gently as it encounters turbulence. For hours it had been a fixed point in a motionless world. Now it's part of a system again. The surface pulls it upward faster. The controls require more adjustments. Sound increases. The clicking of shrimp, the rumble of distant currents, the faint resonance of machinery filtering through the hull. The pilots continue to monitor everything carefully, their attention narrowing to instruments and timing. The end of the dive is near, but routine remains strict. No one relaxes until the pressure outside matches the world they left. The first real light arrives somewhere around 200 meters. It's pale and diffused, scattered by the water above. It doesn't look like sunlight yet, more like a memory of it. The blue becomes brighter, then shifts towards silver. Shadows appear for the first time in hours. The pilots switch off the external lights, letting natural illumination take over. The difference is striking. For the first time since the beginning of the dive, the submersible exists within a visible environment instead of a void. Shapes move outside, fish, jellyfish, drifting debris, all reminders that the world above has always been connected to the one below, separated only by the limitations of vision. At 100 meters, the light becomes undeniable. It fills the capsule through the small observation ports, transforming the grey of the interior into colour. The crew blinks, adjusting to brightness they had forgotten to expect. Shadows sharpen, details return. The surface is close enough now that radio communication with the ship re-establishes fully. Voices come through clearly for the first time in nearly 12 hours. The exchange is simple: status updates, coordinates, confirmation of ascent. But beneath it lies an emotion that doesn't need words. They made it. The pressure that had defined their world for so long is now just a number decreasing on a screen. Breaking the surface is abrupt. After hours of rising through silence, the noise of air and water meeting hits like a shock. The submersible rocks as it passes through the boundary, splashing into the sunlight. The sound is overwhelming. Waves slapping the hull, wind rushing across the ocean, the clatter of the ship's crane preparing for recovery. Inside, the crew shields their eyes. The light feels aggressive after so much darkness. Everything is too bright, too loud, too fast. The human senses need time to recalibrate. The contrast is almost disorienting. It takes a few moments before relief replaces the instinctive confusion. The surface feels unreal, as though the deep was the truth and this is the illusion. On deck, as the crane lifts the submersible from the water, the difference between the two worlds becomes clear. The air smells of salt and fuel. The sound of voices and machinery returns with intensity. The weight of the ocean still clings to the hull, droplets running off in small streams that catch the light. The engineers move quickly, securing cables, checking seals, opening the hatch. When the crew steps out, they squint against the glare of daylight. There's always a moment of silence before anyone speaks, a pause born of disbelief. Hours earlier, they were sitting in darkness under 10 kilometers of water. Now they stand in sunlight, surrounded by open air. The distance between those two realities is measured not in space but in experience. The first breaths of surface air feel heavier than expected. The lungs, accustomed to the steady pressure of filtered oxygen, adjust to humidity and motion. The deck shifts beneath their feet. The horizon stretches endlessly in all directions. It's the same ocean, but it feels different, louder, restless, exposed. After so long in confinement, the vastness of the surface feels unnatural. Some describe it as a kind of reverse claustrophobia, a temporary inability to process openness. The mind takes time to understand that the crushing silence has been replaced by noise and wind. It's not fear, just readjustment. On board, the routine continues. Samples are secured, instruments are logged, and data begins to download from the submersible systems. The scientists gather in the control room to watch the footage, replaying the descent, the seafloor, the slow ascent. Each frame is examined carefully, every detail recorded. The work is quiet but focused. The excitement of discovery is tempered by the precision of analysis. Exploration doesn't end at the surface. It continues in the interpretation of what was seen. The crew knows that within those recordings are answers to questions they may not have even known to ask yet. The deep reveals itself slowly, even after you've left it. For the explorers, the return is physical, but the adjustment is psychological. The sounds of the ship, the rhythm of the waves, the sight of clouds all feel distant for a while, as though part of another world. The memory of the deep lingers, not as fear or relief, but as presence. It stays in the mind, altering perception. The vastness of the ocean no longer feels abstract. It feels personal. To have seen the bottom is to know that the world beneath us is not empty. It's alive, ancient, and indifferent. That knowledge settles quietly, changing the way one looks at everything above. In the days that follow, the memory of descent remains vivid. The silence, the pressure, the faint movements of life in the dark. They return in fragments, often at unexpected moments. Looking at the horizon, the crew knows what lies beneath it now. The sea is no longer just a surface. It's a system of depth, connection, and memory. Each person carries that understanding differently. Some feel awe, others responsibility. For a few, it creates a kind of longing, a desire to return, not for adventure, but for clarity. The deep, once visited, has a way of staying with those who have seen it. When the ship leaves the area, heading back toward port, the Emden Deep disappears behind it as if it never existed. The ocean closes over the point of descent, leaving no sign that anyone was ever there. The waves erase evidence instantly, but the data remains, stored in drives and notebooks, and the experience remains, stored in memory. The deep continues its quiet work, sediment settling, pressure constant, life enduring. It doesn't need acknowledgement, but it receives it through the people who return. The connection between surface and depth is renewed, sustained by curiosity and respect. Later, back on land, the experience begins to transform into something abstract again. In lecture halls, in research papers, in films and documentaries, the deep is translated into words and images. The silence becomes data. The darkness becomes story. Yet those translations never fully capture the reality. They are approximations, necessary but incomplete. The truth of the deep is experiential. It exists not in language but in sensation, in the feeling of pressure against metal, in the absence of sound, in the slow pulse of light from living organisms. The people who've been there can describe it endlessly, but no description equals the moment itself. The deep keeps part of itself beyond reach, even when shared. What remains most striking after the return is the contrast. The noise of cities, the speed of movement, the abundance of light all seem excessive. The deep teaches stillness, and that lesson conflicts with modern life. Yet it also offers perspective. Problems that seemed large before feel smaller now, measured against the scale of an ocean trench. The mind recalibrates. The awareness of depth changes how one perceives everything: time, distance, even existence itself. The Emden Deep, though unseen by nearly all humanity, becomes part of the inner world of those who've touched it. Its silence lingers as a reference point for calm, its endurance as a reminder of resilience. There's a quiet irony in returning from the deepest place on Earth. The journey is measured in hours, but its influence lasts indefinitely. The people who descend into the Emden Deep do so as explorers, but they return as witnesses. They've seen a part of the planet that operates beyond human need, beyond narrative. In that space, life continues without our attention, and that realization carries both humility and relief. It's proof that the world does not depend on us to continue. It exists with or without our observation, and that independence is its greatest strength. Standing again under sunlight, watching the sea move endlessly, it's easy to forget how close and how far the deep really is. Beneath that same water lies a world still operating in silence, storing time, pressure, and life as it has for millions of years. The connection between the two worlds is constant but invisible. Each wave on the surface is tied to currents miles below. Each gust of wind contributes to patterns that reach the trenches. Everything is connected, though we rarely notice. The return to the surface is not a separation from the deep, but a re-entry into the broader cycle that unites both realms. The ship continues its voyage, leaving a wake that quickly fades. The horizon remains empty except for light and water. The Emden Deep continues its patient existence beneath it, unchanged, unbothered by human passage. It holds the same pressure, the same silence, the same slow rain of sediment. The data collected from this descent will add to the archive of knowledge, but the ocean itself will keep its own record. Unbroken, the explorers may return in time, or others will take their place, continuing the dialogue between curiosity and endurance. The surface and the deep will remain bound by the same gravity, the same need to coexist. The return to the surface, like the descent itself, is not an ending. It's another point in the continuous exchange between humanity and the planet. The deep remains what it has always been, patient, ancient, complete, and the people who rise from it carry that patience with them, consciously or not. When they look at the sea afterward, they see not a barrier but an origin, not a mystery to solve but a truth to remember. The Emden Deep waits beneath the same water, silent as ever, holding within it the memory of every descent, every light that ever pierced its darkness, every human breath that ventured into its pressure and returned to tell what silence feels like when it is infinite.